Hello and welcome back to Codeweaver Writes Code. Yeah, I'm going to do some more programming today, which is a bit of a departure from my typical game playing on stream, but that's another thing I do here. I've done it at least once before, and I'm going to do a little bit more again, because this is how I roll. Looks like my stream is up, the audio seems to be functioning all right, and I guess I don't even need to wear my headphones, because there's not really going to be any desktop audio. So, let's just switch over to the other screen. This is my screen. Huzzah, look at that. So, let's start out with the motivation of why I'm doing this. So I'm just going to read this out. Forgive me, I'm not that good of a lecturer, so here we go. Motivation. When solving the very first puzzle in the 2020 edition of the Advent of Code, which I was solving in Haskell, I noticed how the solution I chose, I should fix that typo, whatever, bore a lot of resemblance to one of my favorite elegant implementations of merge sort, at least the merge part of it. I was fairly certain no higher order function specifically existed that could fuse or pair together two lists being processed at different rates, at least not trivially. Hasklers, check me on this. Probably there's a library out there. I'm not aware of it. Doesn't matter. So I set about writing one to see what pitfalls I'd run into and whether or not it was worth it as much as, say, the zip and zipwith standard library functions. Wow, my grammar in this is terrible. The criteria were pretty simple. Try to come up with a higher order function that consumed two lists at different rates and fuse them together according to some kind of external rule. Specifically, should handle two things. Zip and zipwith should be implementable using it, proving it handles a superset of those problems. And it should be able to handle both the merge part of merge sort and the sums to end part of the Advent of Code problem in the sense of finding all such pairs. So I did that, and we'll see that in a moment. C# programmers will likely recognize zip from the link library, C++ as its overloaded transform from the algorithms library, which works similarly. But they don't have this higher order function either. So I did that too, and I'll quickly show that. However, I've gained an interest in learning Rust, so now it's time for the Rust implementation by a Rust noob. So I'm going to close that because I don't want anybody else seeing that absolutely terrible little bit of intro text. I'll have to edit that. So I'm going to quickly pop over to the Haskell version. I'm going to close this, go over to the Haskell version, but more importantly, let's go and look on the right-hand side here. So the basic puzzle that the Advent of Code provided. This is, I guess, part one of two. I guess there's two puzzles in each section. I was going through this puzzle site because I just find it delightful, and the puzzles are kind of fun and sort of less heavyweight than a lot of places like Top Coder and the like. There's lots of great puzzle sites out there, though. Anyway, this one, it basically says, ultimately the puzzle, if you want to read it yourself, go ahead. It boils down to you have a list of numbers. In any order, as you can see. It's not presumed to be sorted. And the idea is to find two of the values that add up to a particular value, and then take those two values and produce their product as the final answer. Now, I'm going to skip that last bit. I mean, it's not hard once you know what the two numbers are to produce their product. So the last part of it isn't really that interesting to me. The part of it that was interesting was when I was figuring out a way to do the first part of the problem efficiently. It turned out that the solution bore a lot of resemblance to what I would have normally done for a merge sort, and that's the naive way of solving this problem, this puzzle, is to go through a list with two different iterators and examine all pairs. Just do a test and check. And for a small list like this one, it would have worked just fine. I would test 1721 as my first number and 1721 as my second number. That would be like the two iterators being here, and then I'd advance. And of course, that one, those two values don't add up to the target 2020 value they're asking in the puzzle. So you would go on to 1721 and 979, and then 1721 and 366. And by doing this exhaustively for the two iterators, you would eventually find all possible pairs. And that works fine. I could have implemented that. But the more efficient way is to take a list and the reverse of that list, and then treat them as two lists. So just treat them as coming from two different sources, which actually solves a broader problem. You could do this with two separate lists, for example. but have it so that one of them is in ascending order and the other is in descending order. And then what you can do is you can walk one iterator or the other so that the sum of the two hovers around the target value that you're after, so that if you have a value that's too big, you advance the list that's descending one. Let me see if I can show you this actually what I'll do is I'll pop open my programmer's notepad, and hopefully that's displaying correctly. Yes, it is. So to show you this, instead of just doing all possible pairs of values, what you would do is you would take, for example, let's see, what is the sorted version of this this list that they've got here? So that'd be 299, 366. What's the next one? 675. Then it would be 979, 1456, and 1721. Now, you can interpret what I'm about to do as either having a list and its reverse as two separate lists, or you can talk about having an iterator that goes, one of which goes forward and the other one goes backward on the same sorted list. It's basically equivalent. But let me just quickly reorganize this. I'm going to treat it as two lists because it's easier to see, and in fact that's essentially how I implemented it. So when we get to the actual code, you'll be able to see what I mean. All right. Right. So be fairly easy to show, for example, that if I take these two values, 299 and 1721, that I would in fact get a hit. Now at this point I can advance, I can effectively advance either one of them. In fact, I advance both of these markers because I found a solution in this case. And what I really, I am not going to be able to get a better value by going up on just one of these. It's not possible because all of these values, I'm making the assumption that these values are unique, so let's just operate on that assumption. But if I advance this one, it's guaranteed to not be the correct answer. So I might as well advance this one as well. The first one taking the value up some, the sum of the two values up a little bit, and the other one taking the value down a little bit. Now it turns out that this is, what is this? This is 17. So okay, so the first sum. Let's actually produce this as a separate list here. So the first one is in fact 2020. The second pair here produces a value which is 17, 18, 20. I'm not going to be able to do that in my head because I'm tired and it's hot. So that's 2, 1 to carry, 11, 12, 1 to carry, 7, 8. So this is too small. It's not our target value. So this one went up more than this one went down. And so we had a net, actually, sorry, that's not true. I have that exactly backwards. This one went up more than this one went, sorry, this one went up less than this one went down. And the net result is a value that's too low. That's the way I'm saying that. So what that means is that the next one we reject as a pair that is of value, but which one of these do we advance? Well, we advance the one that is going to get us closer to 2020. So we actually have to go up in value. So we're just going to do these one at a time, and we may overshoot, and that's fine. In fact, that's the whole point of this, is to continually over and undershoot and occasionally get it right on. So if we advance this one, then the next value under consideration is, see, that's 11, carry the 1, 13, carry the 1, 11, carry the 1, and whoops, I've done that exactly backwards, and then 2. So that's actually reversing that as 2, 1, 3, 1. 2, 1, 3, 1. So, whoops, 2, 1, 3, 1. So that's the sum. Now we've overshot the other direction, and so that's not an answer to our question either. So the next target is to bump up the one which will decrease the resulting value. And so by doing this, we are effectively advancing either one of the lists or the other in order to hover our checked sum, the thing that we're examining in this row, against the target, which in the puzzle was 2020. And of course, it could be any value. And in fact, that's the way I implemented that. Oh, hey, hi, I see I have a couple of viewers. Right, so that's how this solution can be handled efficiently. One way to look at it again is to take a list and the reverse of that list and walk iterators down either one of them, advancing one or the other as appropriate to hover around the target and find the pairs that actually manage to hit. Now, I'm walking through two lists, but I'm not walking through them at the same rate. So this can't be implemented with a standard zip. And because of that, I wanted to look at a way to, when I was implementing a way to do this by walking through the two lists independently, I noticed this resembled a lot the behavior in walking through two lists for a merge sort. So taking the original list of values, and I'm just going to, try not to, all right, so I'm going to grab the list of values out of here. And doing a merge sort, just a moment, we're going to get myself lost in all the windows I have. So if we have a list of these items, one of the parts of the merge sort operation is to do a merge. So if we had these upper few values, which were pre-sorted as 366, 1121, or 366, 979, 1721, and the other one is 299, 675, and 1456. If I have these as, in fact, two separate lists, doing this live is all sorts of fun. So if I have these two separate lists which are already pre-sorted, then I can use the merge operation in order to get a completely sorted list. That's one of the parts of the merge sort algorithm. And the way I would do this is, again, have basically iterators, markers, pointers, whatever, indexes that refer to the first two elements, and then I would simply choose one or the other, whichever is lower, and write them out in order. So I would go to 299, and then this one would advance. But taking a look at the next one is the top one, and that's 366, and then this one would advance. And so on and so forth. And what this is, 675 is the next one. Although this one is, at least for the first few elements, just walking them one after another. This is still not really something that's implementable with a zip operation. So the next one is 979. Right, so this one is in fact alternating back and forth, which is an unfortunate choice of values. But I hope you can see that if, for example, this one were, say, 1121 instead, this would then choose to do the top one 2 times in a row. And in fact, we could end up going through one entire list and then the other entire list if they happen to be arranged that way. So as long as the two lists are sorted, the resulting list is sorted, that's the merge operation. So there's nothing all that interesting about the merge operation as such. It's pretty easy to implement. It's just not something that can be trivially implemented with a zip operation. More interestingly, sorry, had to take a drink of water there. More interestingly, these two operations bear a lot of resemblance to one another. I'm operating on pushing through two lists, looking for something to output as I advance through them. And I thought, well, wouldn't it be interesting if I could find a way to write a higher order function to do this? And that finally is where we stand. So we don't actually need this the advent. Hang on a second. Let's just flop over that. We don't actually need the advent of code thing open anymore. Feel free to go to it. I love this little puzzle site. It's kind of reinvigorated my desire to try out different languages, solving puzzles that are little bite-sized pieces. But we're going to close that because what we're going to do is we're going to go over to, first of all, looking at the implementations they've already done. Because, as I mentioned in the opener, I've already written solutions for this in 3 different languages. And we're not going to go through them individually very deeply. I might do that in a separate video because what I want to do is get to the Rust. That's really what I want to do here. But I originally did this in Haskell, so let's go take a look at that. Oops. Noob mistake. I keep mistaking my OBS window, which I should probably hide, actually, if I can figure out a way to do that. It is not letting me hide. Well, whatever. I don't want it to stop streaming, so I'm not going to fiddle with it. Don't know why it doesn't have a hide button. Let's just flop over to the Haskell version of this. So here is the entire function. I love the terseness of Haskell. I love the type safety of it. It's a great language to work with. It is functional, which means a lot of people coming from an imperative world are going to see this and balk, and a fair few people are going to see the fact that it is sensitive to white space are also going to complain at me, and I don't care. Please go away. I am sure you can make your arguments, but this isn't the place for it. What we have here is more or less the entire function. The idea here is a lot like the zip function, that it takes as inputs functions that take individual items and produce a result, and ultimately produce out of applying that function to individual elements of the original two lists, produce a list of its own. Now, in order for that to make a lot of sense, we should probably talk about how you write basic zip. And when I'm over on the Rust side, I'm going to do that. I just wanted to show that it's really not a lot of code. And in fact, zip itself can be written in terms of my function doing just a little bit of extra code. So this will do what a classic zip does, and it tests it and it works, etc., etc. So yay, that's what the Haskell version looks like. We're not going to focus on that. We're going to move on. The other version of this is the, I guess, the C++ and C# versions of this. I am going to pull those up next. So we're going to turn off that, and we're going to turn off that, and there we go. We should be able to see my the zip operation done for C#, and going all the way back up to the top, and you can see all my little bits of support code here for basically printing things out and doing adds and subtracts in an abstract way, because I operated on a generic type. The actual merge algorithm is right. The merge zip algorithm is right here. And it does very much like what the other one did. It's just a little bit more code, but the basic idea is it's written in an enumeration style so that it can be used as if it were a standard link function. And you can see here that I'm doing individual yield returns as I find values that are relevant. We're going to talk about the fact that I'm using sort of an optional value in here later when we write the Rust version. Don't worry about that, but basically speaking, the same operation or the same behavior occurs here. We're taking delegate functions to we're taking the two lists, one of which is implicit here. We're taking a delegate here, F2, which processes two elements. These are optional lists, which I'm not going to go into at the moment, and it returns ultimately returns a value of the same type. I'm going to go into each of the individual pieces of this when I start up the Rust version of this. But the behavior is essentially the same. And again, we have versions of zip that operate on this. Where is that? That is here. Zip and zip with, just like on the Haskell side, can be written using this merge zip function. Now this corresponds, these are already written in link for you. I mean, don't do this, obviously. These are the, effectively the zip function from link does the zip with operation. And standard zip is just zip with producing a tuple, so. Yay. Not that interesting. Well, I think it's interesting. Let me rephrase that. I think that's quite interesting. But let us pop over to, let's pull up a new project here, and I can quickly show the, no, I don't want to open a new project. Let's see if I can open it up in the standard window. The C++ version of this is here. My main looks an awful lot similar. There's some support code here for dumping stuff out. And so here is, so this zip width is actually written using C++ as standard transform, just to show that there's an equivalence here. The one way in which standard transform differs ever so slightly compared to zip, when you're trying to do a zip, is that it doesn't handle elegantly the case where one of the iterators runs out before the other. It actually expects the first such specified list to be shorter. Otherwise, it just iterates off the end of the shorter list, which I find unfortunate. But I guess it means one less test they have to perform, and it's easy enough to do a quick size check, which is guaranteed to be constant time. At least after C++ 11, I think, is when they made that linear even for lists. Obviously constant for lists. It's definitely constant for vectors. The one difference that this has over the others is this will work on different kinds of collections. I guess that's true of the C# version as well. I tried to make it work over both vectors and lists. Haven't tested that in detail, but it's not germane to this at the moment. A number of other Haskell functions, just so that I could write this in a fairly condensed way. But the big thing here is this bit, the merge zip width, where you can see that this looks an awful lot like we just saw in C#. The one disadvantage here, this design is slightly modified because C++'s production of collections, I guess, is strict, and the element evaluation is strict, and so I can't sort of produce a partial list. I can't do like a yield return like you can in C#, and I can't do sort of lazy evaluations of lists and collections generally like you can in Haskell. And so this one completely takes a standard vector in and returns a standard vector out. Yeah, this one's keyed on vectors. The one up here is actually much more generic, but it's also way harder to read. So this one produces one entire vector from another entire vector, and that has a couple of consequences in terms of the design of this, but it is very, very similar to the C# version. So you can see that here. Let's move on, because we're not doing that either. We're going straight off into trying to do this in Rust. So I hope you had fun with that quick little tour of my code. Let's talk. We don't need that anymore. So let's talk Rust. I don't know Rust very well. Yeah. So what I have done is I started with obviously getting the Rust toolchain installed enough to do a single file compilation. I'm just doing this in a single file. I'm not doing anything fancy with modules. I'm going to try to do this just in one file, just to do the same thing that I did in all of the other programs. And in fact, I'll probably reopen some of those projects to pull over snippets of code. The closest that this is going to probably resemble it's a tough call, because Rust lives in this nice little avenue right barreling between Haskell and C++ or C for me in terms of their equivalents. Yes, it's imperative, but it has non-mutation, which is very functional. It can do a lot of things in a fairly functional style. It has traits that are very similar to Haskell, etc., etc. So there's a lot of, although technically a couple of those things aren't really specific to functional languages. So it is definitely an imperative language. Let's get started. My next task is actually to write a version of zip, which is not the built-in version of zip that Rust has. You can see me using that here, xs.iter.zip, ys.iter, and then you collect it all as a vector at the end, and I let the type specified here float, like it's basically deduced by the compiler, so I don't have to specify it. Same here, but this is a concrete type. Rust is actually one of the more type concrete languages I've ever seen. I love it for that reason. Same reason I love Haskell, actually. Its type systems, frankly, way more solid than C++'s is. So I'm going to get some C++ programs in here being cranky at me for saying that, but deal with it. So we're going to figure out how to do this with a zip. Now I've designed this, or I've taken a look at this, and I see that. Okay, so what I want to do is I want to take these lists, and I want to produce the same thing that that this zip operation does. I effectively want to mimic this. Now that's going to mean me looking up in some Rust documentation, and this is where this stream is going to get a bit slow, on what the standard library zip function actually looks like as an iterator. How do I write a function? So this is a question I can ask the Google. Rust function, Rust iterators. And it's in standard iterator, or standard iterator. I want to be able to use this type. It's a trait called iterator, and what I want to be able to say is I want to be able to give any iterator, any pair of iterators to this that can walk over a collection, and from that I'm going to produce an iterator. And that's very C# link-like. In fact, that's exactly how I wrote the C# link functions. I basically took in a pair of enumerables from which iterators can be generated, and I produced an enumerable from which a C# iterator can be generated. And so I can use that just as part of the standard link chain. Works like a tree, it's just fine. So same thing is what I want to do here. I want to be able to use this as if it were a Rust-like iterator function, basically mimicking zip. So let's actually, what's the best way for me to go looking at that? Now I know you guys can't see. I should actually put something up on screen, shouldn't I? Just to make sure. Why is that not showing my programmer's notepad? Because, there we go. Sorry about that, everyone. We now have code on screen. I'm going to show you I wonder if I can do this. I don't know if I can do this in a generic way. I don't really want to show my entire screen. That's not really my thing. I haven't cleaned up a bunch of stuff on my desktop. So, okay, can I add a panel here, which is add window capture, Rust docs. See if I do that. I guess I can. There you go. That's what I'm currently looking at. I'm just going to put that over here in OBS. So this is the trait that I'm looking at producing, and this trait, the way traits work, they're a little bit like interfaces that you might see in C++, Java, whatever, except that it's not really based on the idea of dynamic dispatch. What it's doing is creating sort of a category to which you can add existing structures as supporting it, sort of independently of the struct itself. They basically, like in Haskell, they've detached the concept of a data type and the functions that support it when you want to abstract over different kinds of concepts, different kind of categories of structures. And in this case, I can say that anything is an iterator as long as I can provide the functions that make it an iterator, except that I don't have to modify the target structure or class to do that, which I quite like. I got really used to it in Haskell, and I really like it as a mechanism for abstracting away types. Plus, separating it out this way, don't know where I was going with that sentence. Separating it out that way means you're not stuck in a situation where you have an idea on how to make a structure comply to a particular kind of category that somebody else may not agree with, but it doesn't matter because you can do it yourself. You don't have to talk to the original author or wrap it up in something. So let's just figure out how to pass around trait objects. What does the zip function actually look like? So what I'm going to do, don't know if this is going to work, it might not. Yes, it does. So we are going to go to we want Rust zip function. Ding. How zip function works in Rust, that's fine. Zip in standard iter. This is what it looks. This is what. This is an iterator that uses two other iterators simultaneously. That's a zippable iterator type. That's interesting. Okay. I did not know that they had, this struct is created by zip or iterator : zip. See their documentation for more. I guess that makes sense, right? To be able to mimic what they have done, I'm going to need an output for this, and the output for this has to be an iterator, but it's not an iterator that's the same as the first two. So I guess what I'm going to have to do is I'm going to have to create my own. Type that is basically, if this is what did we have for iterator? We had iterator being the type of the, so type is going to be an interesting problem. I do not know how to write these trait types, so because these are effectively trait objects, being able to pass them around as independent. Okay. Because I don't want these to be vector t's. I don't want these to be entire vector t's. Actually, I could write a version of this that starts out with vector t's and returns a vector t. So let's actually start with that kind of a version of this. So we are going to say that this is going to return, ultimately, some sort of type, which is xs, ys is going to be a vector that is, and I think we can do tuples this way, t and t. I have to put that under a let. Told you I was a total Rust noob. If this is not the syntax for tuple, I will get there eventually. So this is going to have to be, I think, a mutable iterator, because I'm going to have it taking in additional items. Right. Next thing I'll look up is Rust. Actually, no. Rust vector. Yeah, that's the one I want. And you can see here an example here where we're creating, so we need, this is not how I state this, let mute xs. I don't actually need to specify its type because there's some good type deduction going on in do this? Am I actually permitted to specify? This is actually using vect as a efficient stack. It's talking about indexing, slicing, etc., etc. But what I want to be able to do is do this on something other than just integers. I want this to be as generic as possible. Well, let's see if we can... tt : new. Is it going to let me get away with this syntax? New with brackets. This is how I create a new one of these. And we are going to pop up. I've actually already got a command window related to this command shell, which is hopefully that isn't actually that needs to come. It's going to be a little bit of window management here. Be a little bit annoying. In OBS in particular, I really should figure out a way to do this on my entire screen so that I can just pull Windows off onto a second monitor or something. Let's get rid of the Rust docs. There we go. So let's see if... So it does not like me at all. And that's, whoops, CLS. Let's just quickly, comparison operators cannot be chained. Okay, so that is not how I specify a vector T. So pulling on the standard vector documentation back up here. Yes, I am going after a slightly tougher problem right up front, but that's just what makes it interesting. Quickly reading up on vectors then. A contiguous global array example written as vect and pronounced vector. Okay. But if I just do vec new, and that's fine. Maybe there's some type deduction logic going on here. I'm going to, on purpose, not actually solve this problem. I'm going to go x, s, y, s. And I'm going to use the push operation here. Is it even going to allow me to do this? No, it does not like that either. Oh, and it's complaining about the comparison operators here because I'm doing something dorky. Because I was trying to write this in a slightly different way. So what I can do during a let is I can specify the type like this, which I may have to do up there when I'm doing the definition for XSYS back in my zip. That's fine. That has nothing to do with something to do with my immediate problem. So CLS says cannot find T in this scope. Oh, okay. Can we get away with that? Let's just do a clean every time we do a... Okay, that did not work. I don't know why, because apparently my console foo is... Anyway, so that's zip equals my zip xsys collect. Oh, yes. Okay, so actually what we're going to do is we are not actually receiving this type. We cannot find zip in this scope. That's not really what I want here. Anyway, this is actually going to be... Actually, we're going to leave that as unspecified, and hopefully Rust can work out the type for us. Cannot find console in this scope. Really? Oh, because I pulled this in from... Pulled this in from C# and forgot to make this modification. So let's just fix that, shall we? I'm going to use this syntax for the substitution here because that does a debug print, or a debug. It asks each object for a toString that is debug friendly, effectively in C# terms. I don't need this dump, because that's again from the C# universe. All right, mismatch types. Expect a struct vec found array. Oh, it is. It is in fact an array. Okay. So what I'm going to do, because I would want this to be able to operate on both vectors and arrays, but right now I am focused more specifically on vectors. So I'm wondering if I can do vec new. No, I want to be able to say, how do I, going back quickly to the documentation, how do I create a vector directly from like a list? So it is actually done. That's interesting, and I have this off screen so that you can't see it, but it's actually done this way by using a vec macro, which breaks apart a list, or sorry, breaks apart a multi-parameter. It can, among the things macros can do, is break apart a multi-parameter entry into smaller stuff. Rust does not have operator overloading, and it doesn't have variable length argument lists either. And so their way of approaching that is to use macros in order to be able to do the appropriate rewriting of code. And now, from what I understand, it's not like C++ macros, which are basically pure textual substitution. It's actually closer to like C#'s runtime analysis of the code structure, except it's not done at runtime. So code time analysis of the abstract syntax tree. So you can basically, by using a macro, it could basically turn this effectively into a bunch of pushes into the vector that's involved. And I don't know if I like or dislike this particular feature. I'm kind of indifferent to it at the moment, but let's just see what happens. So we're going to call this vector of x's, vector of y's, just so that we're sticking with something that I can basically push elements into. I'm more familiar with that. So let's try this again. Again, mismatch types. This is a good thing. Expect an array with a fixed size of elements, found one with 12 elements. Okay. Expected vector of integer 9, vector of integer 12. The method collect exists for unit type. Okay. So okay. That's interesting. I don't know what the type of VX's and VY's is. Looking back at the documentation here, let me vec equal vec bang 1 2 3 push an extra element of 4. Yeah, okay, so that should be producing me a vector. I'm not keeping the element around for longer than I need to. I could actually go for VX's. I don't want to convert that to an iterator. I want to pass the entire vector in for this particular version of this. So the next question is, So it expected struct 9 and 12, and I think the reason for that is when I was originally doing the original zip, I had a similar error to this that involved saying that when I was passing arrays in, that the two arrays were different. So I guess arrays being fixed length types, a lot like C has them, for example, their length is actually formally a part of their type. Now, the minute I changed this to grabbing iterators, that was no longer the case. Isn't that interesting? When I did the iterators, this was no longer the case, because if you have two iterators, you don't know how big your collections are. You just go until you get to the end. So it's interesting that when you're zipping, it looks like when you're passing, when you are trying to figure out the type T, when you're trying to figure out the type T, like when it's trying to do the substitution, its fixed sizedness matters, and these have to be basically identical in type, not only in terms of the fact that they both contain, for example, integers in principle, but also that they contain the same number of elements. That's weird to me. I'm pretty sure that if I shortened this by a few elements, because one of them is 12 units long, so if I took this and chopped off 3 elements, pretty sure this would actually potentially start working. The method collect exists for units, so this is at the end. It cannot be called due to some unsatisfied trait bounds. Following trait bounds are not satisfied. Because I'm not returning anything. Another thing I like about this, type deduction of return types. The return type forms part of the chain of type analysis. There's no automatic conversion as far as I can tell in Rust of any kind, which is good. I don't like that in C++. I find that a source of considerable error. So what do we have here? So here we go. I did the return, but it expected unit, which is basically return nothing, and found struct vec. Okay, I guess I do need to provide a return type. That was a fib, and that's fine. I'm learning. So it's vector of. All right. So this is going to have to be. So there we go. Really interesting, though, that why is it deducing? Okay. Hang on, need to clean this up. So this parameter, expected vec because of return type, expected type parameter T and found integer. I can't actually cheat and do this. So what we're going to do is we're going to push xs0 and ys0 because unlike C++, which sort of monomorphically it takes a template, substitutes a real type for T, and generates a brand new function full of that item. And so I could, if the use case that I put it to was an integer, I could the instantiation would have worked with these being integers, because T would have been integer, but then these would have been as well, and it just would have worked. But in Rust, kind of like Haskell, inside and a little bit like C# for that matter, once you're inside a generic function, you don't know what T is, even because even for specific instantiations. Like, that's a bad way to say it, and I don't know the formal language terms for this. But even though my only use case is integers, this still has to compile for all T because I'm not placing any constraints on T. And so, regardless of whether or not it actually spawns off a new copy of this with int substituted in place of T, as far as compiling it in the first place, as long as syntax checking it in the first place, I can't make any assumptions about T inside here just based on use case. I have to make it generic at all times. So I can't cheat. So let's see if that works, because that's at least grabbing the first two elements. Oh, note the following traits were not satisfied. Method cannot be called due to unsatisfied trait bounds. Okay, this is going to be all sorts of fun. The following trait bounds were not satisfied. Vec integer 9 and 9, which is required by mute vec integer 9, 9. Because... the method collect exists for struct vec integer 9, but its trait bounds were not satisfied. Okay. I think part of the problem here so I'm not sure this is the proper way to pass in a vector T, because I kept being suspicious. Hey, more viewers, look at that. I kept being suspicious that it kept reporting T as being an entire array, which is not really what I'm after, because T here, what I'm actually after, is T being integer, and this specifying a type that is actually a vector. So quick check and go. And I know passing, like I totally know for anybody who's still paying attention to this stream, I know that I should be receiving iterators here to make this more general, but that's not what I'm currently after. So Rust passing a vector. Yeah. So passing a vector into a function. Best way to pass a come on, this can't be that difficult here. Pass a vector structs. Okay, pass a vector by reference. No, that's not what I want. Well, this actually may be what I want, because I don't want to, it is true, I don't want to actually consume the vector in main. One of the things that takes a lot of getting used to in Rust, and why this is going to be a long stream as I figure this out, is that its borrow checker, its mechanism for doing memory management, requires me to identify basically whether or not a function is going to consume its parameters permanently and become the owner, even if it ends up passing them back out to give back the ownership, or whether or not it's receiving like a reference to it, but then it has a lot of restrictions on what it can do with it. The language is very, very strict on knowing whether or not a function consumes something or produces something, or whether or not it's just passing around references and things. More so than it does in C++, for example. In C++, you can pass a reference to something, but then the caller can do very nearly anything it likes with it. It's not considered to own it, but it can monkey with it pretty badly. But if you pass a something in that is meant to transfer ownership into the function. You no longer have access to it in the main function, which is actually a good thing, because it's the way you can basically do memory management without actually having to have news and deletes, which is, I think, a fantastic hybrid between, like, it's a way to get memory management that doesn't require explicit memory management in quite the same way. It also makes sure that you know exactly who owns data at any given time, and that's really hard to guarantee in C++. Who can delete an object from the heap, for example, is always a big question. It's more by convention than by language design. Rust tries to build it right into the language design, which I find fascinating, but hard to wrap your head around. So anyway, where were we? Let's get back to this. Passing a vector into function by reference. No, I need to pass a vector as a parameter. And so okay. It looks like I have the right of it. It is actually vect, I think. Okay. So to show you what I'm currently looking at, because that's boring for you guys to just watch me not do anything in the programming shell, let's just quickly pull away the command, and I'm going to pull up the Rust docs page. So I'm basically looking at not the crate stuff. Is that going to show up? Yes, it is. Fantastic. At least if I keep that one window open, I can show you what I'm looking at. So basically, you can see passing in a vector looks a lot like this, which is more or less what I have, except I just have it being templated on type T. The thing is, I'm still not entirely sure why I'm getting this error message that is talking about. Now I got past the point. I got past the point where it was talking about the two vectors being the wrong length. I'm going to put that back in actually for a moment, now that I kind of understand what's going on here. Okay, so here we go. Back to OBS. Turn off the Rust docs, turn on the command shell. So I'm back to where I was a few minutes ago, where it's complaining about the fixed size number of elements, but the myZip function is only taking, as far as I know, is taking a type of integer. So let's say I just type I can't remember if this is an actual type, it's either int or integer, but let's actually get rid of the genericness of it. Let's take one step further back from that, because I'm fighting too many things at once here. I'm fighting a combination of the borrow checker and some type stuff. So we're going to push a tuple containing 1 and 2. And so let's see what this does. I32, so cannot find int type in the scope. So yes, that's fine. I32. I'm totally fine with being schooled on that because I don't know my Rust types yet. All right. All right, so CLS, let's do Rust. Mismatch types, expected I32, found array, integer, some generic integer type 9. So maybe my problem here is that I've got this this vector macro that I don't quite understand the type that it is producing. So hang on, let's actually make this explicit. I actually want this to be a vec I32. Once I'm more used to these Rust types, this will probably become less and less of an issue. So mismatch type, found array, expected I32 found array. Okay. Let's try this. Let's try searching in Google for Rust initializing vector with values. That's what I did wrong. Right. Okay. So the vec macro, I would love to know how this actually works, how macros work without parentheses, but apparently the way I do this is this. Yeah. And that would actually explain something, because what I effectively did was I turned the entire thing into a single parameter to pass vec. But what I really wanted to do was pass, I guess, what would be considered an initialization list in C++, basically something that is specifically indicated as being a set of parameters to be passed in. That's not quite true either, because that's more or less just a fixed array in C++. What would be the best way to say this? Because I'm passing this to a macro, this is a little bit like passing a list of items to a variable length template parameter list that generated a bunch of function calls. So originally I was passing them as a one item, which is why I kept seeing the type being fixed array of values when like as the t here, which was a big problem, right? Because what I really want is a vec int. I don't want a vec array of 9 items, and that's what I was getting. So now that makes a lot more sense, and it also makes sense now actually why the lengths mattered in at least that case. Because yes, it makes sense that arrays in Rust are typed by their length as well as their actual type. So these were very definitely, it was a vec of 2 different t's, right? Which made no sense when I was trying to get them both to be integer. It makes a lot of sense when it's 2 different arrays of integers. So now I've unpacked that. Let's see if that changes the nature of the bugs. Sorry, CLS. Let's just get a nice clean look at what we're dealing with here. The method collect exists for structs vec I32, I32, but its trait bounds are unsatisfied. The method cannot be called due to unsatisfied constraints. The following trait bounds were not satisfied. Okay. Vec I32, I32 iterator, which is required by a mutable iterator. I need to return I'm returning an entire vector, but the thing that collect requires is not based on having an iterator. It's based on having collect needs an iterator, but what I've produced is an actual vector. So what I actually want to do temporarily is this, I think. Now the other problem is actually VXS and VYS are going to be consumed by this, because I'm passing it in without being a reference, but we'll solve that in a second. So, warning, unused variable XS. Warning, function myZip should have a case snake case name, because the convention is this. Not sure how much I like it giving me warnings about that, but I guess this is always the problem, that in a lot of languages you end up with 50 different people writing slightly different variations, standards, code standards, and by sort of hinting at a particular suggested standard for the community, eventually you might get people to code in a similar fashion. I guess I don't have an objection. I do this for C functions all the time, or at least I got used to that way back in the day, and now I use camel case for a lot of my stuff. I don't care. I can adapt to this again. This is fine. In fact, I do use this. I don't know why I'm whinging. But it actually got through all of that. And actually, if I actually do a run of that right now, so that's merge zip. So we're going to do that. Really? Dot is not recognized as a... You going to run for me? Probably going to... Don't think I've excluded this folder from my antivirus software, so it might take a few seconds to get past that. Okay, so let's take a look at this. So the output of this program, this is the first time we've seen an output of this program. Oh, hello. This is just 50-50 light mode, dark mode to annoy everyone. Your zip function looks a bit over-engineered. May you explain the purpose? Yes, I can. Okay, so... the first comment about 50-50 dark mode. No, it's not specifically done that way. Programmer's Notepad just comes up as black text on white, and the command prompt by default comes up as white text on black. Yeah, I didn't expect that to be a comment. I suppose that's a valid thing. Okay. Sure, why not? Selected screen colors. Make that white-ish. And then the screen text, we can make black-ish. Oh, except that makes the colored text really awful. Alright, hang on, because I'm not fond of that green on the white. Really? You're making me change the colors? I think that's a bit pedantic, but alright. What can I do that's actually going to not make my eyes cringe? Maybe I can go with that. No, that did not work. No, I can't actually figure out how to change that text. I don't know what it's going to do. Alright, well, you know what I'm going to do? I'm going to restore this back to normal because I don't want to fiddle with this live for the next 20 minutes trying to get something that satisfies me. So you're just going to have to suck it up. So that's the screen text is going to be white again. The screen background is going to be black, and I will fix that for some future test. So that really bugs you, deal with it. I'm just not going to live on stream. Your myZip function looks a bit over-engineered. May you explain its purpose? The point to the myZip function from the start of the stream, I basically explained my motivation for all of this. I'm eventually going to get to a specific version of the zip that can handle things like the merge sort and the advent code puzzle that I mentioned at the beginning, which tries to find a value in two values in two different lists effectively that sum to a specific value. Because I noticed some commonalities in that. I thought, hey, it'd be fun to try to write a higher order function to do that kind of zipping, which requires processing lists in at different rates. And I did this in 3 other languages already, not on stream, and I thought, let's do a Rust thing. And then I decided, hey, why not throw this on a stream? So that's where the motivation is. But to get there, I need to learn Rust better. And because I'm fairly big noob at Rust, and I haven't done any of it in a while, and not very much of it besides. And so I'm rewriting the standard zip function to get myself better at using Rust, and to eventually make my way towards the actual merge zip that I showed at the beginning of the stream. It's sort of the motivation. Over-engineered, I guess. I mean, right now the problem is that the vector in question, I'm passing in vectors and returning vectors. What I really should be doing is passing in iterators and returning iterators, because then the inputs can be iterators from anywhere. But I'm not there yet. I wanted to start with vectors and migrate my way to iterators, because doing the iterators requires me passing around trait objects, which I'm not familiar with yet. I mean, I kind of know how they work, and I've written a little bit of code with them before, but it's too far in my mental past. So, having done this, let's get back to the code. The code currently as is uses two zips that use a standard zip operation, and you can see the results. It's exactly what I expect to have happen when I operate on iterators. And now I'm going to do my own. Now, my own, I'm going to mark this 2, so it eventually shows up better in the output. But this is where it should say 2. And right now I'm just outputting 1 and 2, and that's obviously just because that's what I baked into the output of this thing. So let's try to actually do this and generate an appropriate zip operation, assuming we're operating on vectors as a whole, which is kind of terrible, but there it is. So what I really need is to go and find to go and find in my documentation how to, I don't need to know the internals of an iterator specifically, because, well, maybe I do actually. What I want is let moot iterator on x equal x's dot iter I y, operate on my y's, and actually I can effectively iterate on both at the same time. I'm not sure the best way to do that. That's an interesting question. I can just write a while loop, but I prefer to avoid. Okay, Rust collection process and collection iteration over a vector. Processing a series of items with iterators. Here we go. So yeah, so there's a for in syntax, which is not surprising because that's exactly how you do it in C# and Link, and a version of that is how you do it in C++. You don't do it that way in Haskell because you don't use loops in Haskell very often, actually at all, really. But let's so we can get rid of this because that's just nonsense. So we're going to do a for v in, so actually we're going to use x, for x in, and actually we can just do x's dot iter, and then there's going to be, do we use the, what's it called, almond bracing? I can't remember what the bracing style is called, doesn't matter. I can get used to that too, which means I should probably put this up on that. There we go. Everybody happier? I really hadn't considered I was using inverted color schemes. That's hilarious. Oh well, next stream. What are you gonna do? Right, but while I'm doing this, what I can also do is I can get rid of that because I'm not going to need it. I will keep this one. And now I should look for some syntax where I can somehow bury initialization of this in the start of this for declaration somehow, this for loop. Probably not. But what I can do here is I can go iy dot, and I think is it next? Let's go and take a look at the next method, iterators in the next method. And so there's a next thing, it's mutating on self, so it itself has to be mutable, but that's okay, that's what I've done here, that's totally fine. And so I do want to make sure that as I enter this, at any given point, if iy, how do I tell whether an iterator is effectively empty? methods that produce other iterators. That's fine. Oh, it's going to be a lot of fun when I get to closures, isn't it? I'm definitely not getting through this on one stream, but it should be a lot of fun. Because what does the function actually return? It returns an option of self item, which means if it's like other options, like the optional in C++, for example, or the nullable types in C#, I'm willing to guess just on the signature alone that the option item returns return some sort of variant that's either an item or nothing. So, okay, so how am I going to do this? Rust option. Standard option. Here we go. Options and pointers, nullable pointers, representation, examples. Okay. And so we need to do some pattern matching, basically, on the option in order to be able to pull out a relevant value. So what we need is something like if I do like pattern matching as well as something I got really used to in Haskell, to be able to pull out structural pieces of a value conditionally on matching against things. It's great. It's a fantastic idea. So this is actually going to be kind of a possible X. So I'm going to say if some X, if let, so I do a match, or I can do a match statement, or I can use an if let in order to do effectively the same thing. If let some X is equal to possible X. I'm hoping that's a logical and, because what I want to do before that is possible Y equals ys dot, no, sorry, it's equal to IY. You have a Rustation ever coming into this stream, come say hi and tell me why what I'm doing is absolutely ridiculous. But that's okay. I will learn a lot about the semantics of the language, even if this is not a traditional way to do this sort of thing. So what I need is standard iter Rust. Very specifically, I want to know how to extract values from an iterator manually. So come on, tell me please. It's actually the next function. In fact, it's exactly this. The next function is the only thing the iterator has on it. So actually what I want to do is this. So this is a very C# style of doing iterators, where the act of doing the next, actually, except that returns a Boolean, but basically you have to call it at least once to advance it into a valid position. I'm very much used to the C++ variety, where the minute you get an iterator, it already refers to the first element. You don't have to do anything. So what this should do, though, is can I actually do 2 lets at once? Well, let's try it. This probably won't work. Equals possible y. Possible y. So we're going to look up Rust if let. What we really want is an else here. If you're getting used to using brackets in that sense, we're gonna break out of this, because if either one of them we can't get one from, then it will fall out. Now, actually, hang on a second. So this is not actually correct. This is actually supposed to be x, because we already. There we go. That's better. Because this is already going to pull out each value, and the only reason, it's going to handle under the hood the processing of that optional. But for me, I've got to do that manually on the IY. So if we can't get a y that corresponds to the x, then we break. And if we can get a y but we can't get an x, then the x, then it will actually fall out of the outer loop before we even get in here. So I think this should work just fine. In fact, what this should enable us to do is xsys.push xy. Anyone want to bet that this is going to explode horribly? Let's find out if this is going to explode horribly. I'm excited. Are you excited? Cannot find value possible y in this scope. Oh, because I didn't do a let. Because I'm an idiot. Let's try that again. Expected vec I32 because of return type, but it found a reference to a I32. Okay. I'm a little confused here. Because, that's interesting. That's really interesting. Okay, so note, expected a struct of a vector of integers, but instead found a struct of a vector of references. And the reason for that is because, again, of the borrow checker. The vector owns those integers. And even though it doesn't have to be neutered, deleted, or I guess under the hood, it doesn't have to be allocated and deallocated in quite the same way. It still follows the same borrow checking rules, I'm guessing. So what this implies is I can't return elements. I'm getting back effectively by doing the access of the elements. I'm getting back sort of a borrowed value from the vector. And so what I'm publishing is a vector of effectively borrowed values. I'm not making copies of those values. I don't own them. And so I don't want to just return references to the original elements, because I want this to be a legitimate copy of the vector in question for this particular kind of zip. So rather than change this to return the type that it's expecting, which would probably work, instead what I want to do is I want to actually clone the values that are in the vector. And the question is, how the heck do I do that? Nope. I'm going to look up Rust clone value. So it does say here, in Rust, some simple types are implicitly copyable, and when you assign them or pass them as arguments, the receiver will get a copy, leaving the original value in place. These types do not require allocation to copy and do not have finalizers, so the compiler considers them cheap and safe to copy. For other types, copies must be made explicitly by convention implementing the clone trait. Okay. These are I32s, though, so that should imply... Well, okay, here's the thing. If I say let mute xsyx and I give this a type vec I32, vec tuple of I32, how is that going to affect the output? Mismatch types. Haha, here we go. Because the I have to dereference the borrow. Help consider dereferencing the borrow. I have to say, although it's tough to sometimes get Rust programs running, at least at my stage of understanding of the language, the error messages once you start parsing them are actually really helpful. Like I like this message. So it expects an I32 and it found a reference to an I32. So effectively, again, it is more or less what I was saying. I have to find a way to say I don't want the borrow. Like I have a borrowed value. The for value is pulling out a borrowed value. And actually, so is the y. The iy.next is giving me a borrowed value. And in fact, if I look up, I'm willing to bet, if I look up in the... I've made it go away. That's really unfortunate. I'm going to have to look that up again. So Rust iter. To leave that open from now until the end of time. Oh, hello, good gravy. I'm already up to 5 viewers, at least at some point in the history of the stream. Hi, I'm a Rust noob. Yes, I'm going to make horrible mistakes, and somebody has already commented about the color scheme that I accidentally chose. It didn't even occur to me. Deal. So I'm currently attempting to manually implement zip, starting by implementing it on vectors rather than iterators, in order for me to understand sort of a more basic function than what I'm actually after, and to really understand all of what I'm doing. You have to go right back to the beginning of the stream where I explain the motivation, because I don't want to ramble all that off for the third time. But I am trying to write a zip function, and so I'm understanding the mechanisms of the borrow checker and the way the type system works. And I'm coming from a C++, C#, and Haskell background, and so those languages are floating around in my head completely willy-nilly, and so they're going to cause me to stumble quite a bit on the syntax of this. But I'm still loving the process, so I hope you stick with me. If for no other reason than to see me faceplant regularly. I am not in any sense an expert on this specific language, so please don't take it that way. Find someone else if you're looking for hints on how to code in Rust. What you'll find here is me learning how to code in Rust. All right, so back to where I was. So my thing to understand here is what the iter value's next function actually returns, because its function signature could be interesting. And yeah. It's not completely clear to me, but I'm not going to pop over to the document I was reading. So looking at this description here, We found expected I-32 and we found referenced I-32. So it wants, the tuple wants me to give it, as part of its construction, an I-32 alone. So what I'm going to do is I'm going to look up Rust. Rust, what is it? It's asking me to dereference. Now that implies like sort of a pointer-like activity, but I want to differentiate between simply dereferencing an item for type purposes, I guess, and actually doing a clone operation. So we're gonna bring up another tab here, which that I will flop over to. God, I find a better way to do window management in this. So where are we going? Rust docs. Doink. Oh, some local fun and happiness. I'm in a big city. What do you do? This is with my windows closed too, but whatever. Yeah, I do not have a soundproof room. So Rust, dereferencing mute. No, dereferencing. What is this? What was the actual wording on that? It's consider dereferencing the borrow. And that's sort of implicitly what I understand I want to do. Dereferencing borrow. Quickly looking up on Stack Overflow, amongst other things. Why do we need to call... okay, so... This is involving boxes, which I don't want to involve myself in yet if I don't have to. So, Rust borrowing and reference tutorial, where can I get to it here? So, reference and borrowing in the Rust programming language. Very rapidly trying to find an example of sort of what I'm after with some understanding. So, so I'm borrowing S. I don't want to borrow it as... don't think I'm borrowing it as mutable, because when I'm doing the for X and X is iter, I don't think I'm actually pulling out. I wouldn't expect that the for in syntax or the call to dot next is returning something mutable. It's not a mutable borrow, but I am borrowing it. So the question is, how inside? I mean, simply putting an ampersand in the code because it tells me to is not, for me, a solution. I expect what this is doing. Brain not functioning. Come on, where's my... There it is. Nope, that's not what I want. There we go. Pointer X and pointer Y. If I do this, it's probably actually going to get past that. And yes, it is in fact compiling, but I don't understand the nature of this here. So it found expected I-32. So in order to construct the tuple, I needed to give it an actual I-32, and it found a reference, a borrowed item. Because it's a borrowed item, it wants me to make sure that I know that I'm passing it off to another container, which it itself has to own it. A tuple owns its elements, just like a vector owns its elements. So the implication here is that the constructor for the tuple will not even accept a borrow and do any sort of attempt at cloning on its own. That responsibility must be left up to me, I suppose. Wow, I'm going to have to read up a lot more about that. So I don't want to make a mistake on that. Now, none of the things, so the vector I32 probably, like, it'll own all of the integers inside it as well. So when I do get an x out of here, it's a borrowed x. So I should probably read up on the vector, what the iterators actually return me to know how that's actually behaving. I'm going to get so lost in the borrow checker. So let's actually run that and see what happens. And we'll take a few seconds while my virus scanner grinds on it, because sure, why not? Let's make life more complicated than it needs to be. Check that out. I have my own version of zip. Just barely understanding the borrow mechanics that's involved here, but that's not half bad. Now, the problem with this is that it's not using iterators, which I kind of want to get around to doing. But there's another problem with this. If I go and do what I did in the previous bit of code here, where I do the zip in both directions, like with each of the lists operating in both ways, what I'm going to end up with is, so it's going to be ys equals zip xs, ys xs. I expect this to complain because, again, I think the borrow checker. So if I try to run this, yes, I do. So use of moved values. This is one thing I have to get used to over almost every other language that I've used, because I think Rust is fairly unique in using a memory management scheme like this. The act of me passing these items, these values, into my zip, I have given it permission to own it. The function itself now owns those values, which means here it's not unlike C++, where I would still have these values, even if these values were altered at this level, like by a move operation. C++ would allow me to do this. The best thing that could happen is that my zip didn't do anything to those two values. The worst case is that it replaced it with garbage or zeroed them out. But in either case, it would actually compile in C++. It won't compile here because the act of passing values to a function consumes them when they are passed in this style. What I really want to do is I want to basically pass these by reference, you could say, but basically the idea is I want to say, I'm just lending these to you. I'm not actually providing ownership. And that does mean that inside there are certain things that I can and can't do with those values. But let's do that, and let's see if I can make this work. Referencing and borrowing. Yeah, it's going to be fun. So I think it looks like the ampersand comes in front of the type in this language. So let us make this a reference to a vec32. This doesn't mean it's mutable. It just means is basically sort of, I guess you could call it a const reference in C++, but what it really is it should be saying, I give you permission to pass in this value as like a borrowed value, effectively. So that did not work at all because I have to do the same thing on the other side. Nope, that's not where I want to do that. I think this will work. Yes, it will. And now, if I run... Really? I think it's actually this. Yeah, there we go. PowerShell has forward slashes, and standard command prompt does not. And there we go. My zip function works just like it does in the C# and C++ and Haskell versions. So, but the zip isn't really all that interesting. And in the long run, I want to write this in terms of the more elaborate version of this that I intend to write, which is the actual merge zip that I showed at the beginning of the stream. Right. Okay. So this now works on borrowed vec I32s, but I don't really want to operate on borrowed vec I32s. I want to actually operate on iterators, and more to the point, I'm perfectly happy consuming an iterator. So we are going to change this where instead of passing in x's and vy's and vx's, I'm temporarily going to comment one of these out because I only want to get one set of errors. I'm now going to delete the references, and I'm actually going to basically create an iterator how do I want to do this? My first way is to create a straight up function that except that I have to pass in, I have to use iterator traits to, an iterator trait, like I have to use a trait object to do this. In order to make it compatible effectively with the rest of the iterator systems. So first thing I'm going to do is I'm going to start by assuming I'm going to have to do this. And eventually I want to vys.iter. Eventually I want to be able to pull one of these outside this function, but I'm going to do that in a moment because I think the only reason I would need to necessarily do that the iterator that I get back, here's the problem. The iterator that I need to get back has to be compatible with the collect operation. At the end of the day, the iterator has to behave like any other iterator trait and be able to eventually have collect called on in order for it to behave like this. Okay, that's going to mean that right away okay. Yeah. I'm doing this in a very hot room and I'm starting to run out of steam, but that's okay. Right, so let us, that is not showing up in the same, make sure that as long as I have the, now I guess I accidentally, can I actually get both of these on screen at once? I might be able to. Or to make that actually, how about that? Does that work? Yeah, that works all right. It's not fantastic, but it'll do. I need to basically look up Rust trait objects. Trait object types. So an example of a trait object. The purpose of trait object is to permit late binding of methods. Calling a method on a trait object results in virtual dispatch at runtime. Is this actually what I want to do? Let's actually be more specific. Rust making your own iterator. Iterators, Rust by example, implementing iterator. Here we go. So if you find yourself with a collection of some kind and need to perform an operation on all the elements of said collection, you'll quickly run into iterators. Okay. The heart and soul of this module is the iterator trait. The core iterator looks like this. Because what I would like to do is basically be able to pass in the three common types which can create iterators from a collection. Iter, which creates iterates over reference. Okay, so that's where the reference came from when I was iterating over my x's and y's in zip. So that's, there we go. It iterates over reference to t. Iterator mute, which iterates over reference to a mutable t, and into iter, which iterates over just t. So arguably, actually, what I could do is I could have made that into iter instead of just iter, because I didn't actually want a reference to the original item. I didn't want to modify the original item, I didn't want to borrow the original item. I could get copies out, I guess. This way works fine. I'm okay with that. So implementing iterator. So that's how to implement a custom iterator completely. So there's a counter. So their example here shows how you might use a counter, turn a counter into an iterator. So, and note that iterator also provides a default implementation of methods such as nth and fold. So there's lots of interesting things into in iterators that are provided for you by with a default implementation, which is good for me because I don't want to implement more than I have to. Thing is, I'm not really implementing a custom iterator. What I'm actually doing, is producing. I guess I'm producing a new iterator. What am I doing? I'm not actually producing a new collection. Technically speaking, I'm adapting two iterators into another iterator, and I'm doing basically what zip is supposed to be doing. I don't actually want to iterate over a new collection. Okay. So let's look at this a different way. What we want is Rust composing iterators. Now this is more or less what things like filter and zip do. They take in iterators and generate a new iterator based on them. So don't want to implement a completely custom. How to write a Rust function that takes an iterator. So what do we have here? So find min, a function like find min, for example. I know the tick marks have to do specifically with helping trace the ownership of values through functions, and I still need to learn that. Traits can be used in two ways, as bounds on type parameters and type trait objects. The book has a chapter on traits and a chapter on trait objects that explain these two use cases. Additionally, you want to take something that implements into iterator, as this can make the code calling your function nicer. So interesting. This is going to take me more time than I thought to figure out. Play Rust Lang. Hello, we got something from Silent Z here. Playrustlang.org. Okay, I will take a look at that link. Why not? Oh, check it out. Zipfex. Neat. All right, I got that open in another panel. I will take a look at this. So I can't show that on the main screen here, but it looks like... Oh, I love the use of the while-let is cool. I'm glad there's a while-let as well as an if-let. That's really, really cool. In this loop that he's got here. And it's using a tuple of lets. Sorry, a tuple of the AI, the next calls for both of the iterators at once, stuffed into a tuple and then deconstructed out of the tuple in order to match against a pair of sums. Sort of similar to what I've got. In, hang on a second, up here, it's basically doing both of these operations, two of them, one for the x and one for the y at the same time. Basically, possible x and possible y would be in a tuple on this side, and it would be deconstructed out of the tuple on this side, which is more or less how Haskell does it when you want to deconstruct multiple objects. It should have occurred to me to possibly do that. And then the resulting push operation involves calling a clone. And I can see that he's doing it specifically on vector t's, as long as t, I guess, is clonable or implements the clonable trait. I will have to look up that syntax. That's really cool. I like that. That's really compact, too. Constructive vec with capacity. So it's basically doing the same trick as I do in C++, where in an extensible vector, before, like, instead of just doing this new, so I haven't made these all T yet. Very good observation. Instead of just calling new and then letting it auto expand, the problem is, in order to be efficient, an expanding vector often has to have some sort of scaling factor in the capacity of the elements that it's storing, expanding by a factor of 2, for example. Sometimes it's some other number. Doesn't really matter as long as it scales up. I guess it would be geometrically, so that you get sort of amortized time in being able to expand it over the lifetime of the vector, constant time, amortized constant time over the life of the vector. Basically, so that you don't have to keep reallocating every time you just push one beyond the end of the vector. I can't actually run that on my test. How am I going to pull that up? Because I got to transfer that text from one machine to another. Yeah, give me a second on that. I can probably pull up in a separate window, because I've got viewing the stream I've got on my laptop. I'm doing my main work in my test cases here. I really like that implementation, and it's what I need to get to. I'm just getting stymied by a little bit by the slightly different syntax, and I keep worrying I'm going to run afoul of not understanding the bar checker in Rust. But give me a second. I can totally do that. So I'm going to open up Twitch on this box. Yeah, this should be fun. I haven't opened it up on this box in a while. Video producer. Oh, except I'm not going to have the text available because it's in the past. Okay, hang on. I'm going to... This is going to be a fun thing to try to do. Where can I dump this that both of my machines can actually see? Give me a moment, everyone. I apologize for the delay. I don't have a really good place to even dump the have solved this problem a long time ago. How could I not have a way to do this? Okay, here's what I'm going to do, because this is just completely silly. I'm going to take that, I'm going to replay it back into chat once I've got my other computer looking at it. I should have a Discord server with just like myself on it to paste myself things between my machines. I just don't have a really easy way to transfer it between one and the other fluidly while I'm also doing this streaming. So let's just go back to Twitch TV. Let's go over onto my account. Let's go into the channel. Oh, look at that. It does maintain a little bit of a list of the past chat. That's easy. Okay. I feel dumb. All right, so the code I'm going to paste in now is going to be a version of the zip function that was supplied by the chatter SilentZ. So this is all his, and I'm going to erase it immediately afterward after I test to see whether or not it works. But here's the zip vex. This is going to be a lot of fun. I love this. This is a great way to learn. I don't mind having example code for stuff that I've sort of already done, because that means I can learn better ways to do it. So let's just run my test examples. I'm just going to run the one, because that's technically, I mean, I could run both. It's not really going to change anything. Why don't I run both? All right. So I'm going to do mine and then theirs, I suppose. Zipvex, here we go. Oh, except I've got to made mine into, that's dumb. Made mine into iters, so let's get rid of that. Like I have to figure out how to do this with proper iters, because I love to be able to process collections in this sort of iterative, composed iterator functional style. Makes me very happy. I love Link. I'm going to love C++ ranges when it gets around. And I don't need to call collect because we're actually returning a new vector, I believe. What is the result? The result of zipvex is in fact a vector of T and U. Also, did notice that you have T and U because they don't need to be the same. I appreciate that. I should have noted that when I originally started this up. And obviously that's the right way to write a zipper because they don't need to be the same types. So this is going to be specifically SilentZ's version. Silent, again, I'm going to get this right here. Silent_Z. There we go. And we're going to pass this in as well. Is yours requiring... yours is a vec_t, so it's actually going to consume them. So the one change I'm going to make just to be able to run both is I am going to make these non-consuming of the vectors. Actually, you know what? No, let's not do that. Let's not change your code before we have to, but it will consume the vectors in question, and that's fine for now. So let's check out this version. Hey, live experimenting with other people's coding. I love that. Let's do a compile. All right, so it did not like that, and the reason why, mismatched types because, yeah, that's wrong. That's just totally wrong. And actually, let's comment mine out because mine doesn't operate on iters yet either. That's still obviously a work in progress. So that was my fault. Let's do that again. Cannot find, right, so, because I'm an idiot. And that one will eventually get working, so there we go. Function never used by zip, don't care. One warning emitted, dead code, don't care about that either. Let's run it. Let's check this out. One thing I miss is that the function should take references and not ownership of the vex. Hey, yes, so I didn't even read that before I commented on that. So yes, okay, so I guessed correctly. In that case, taking slices, like ampersand array bracket t array bracket is better than vec t. Clippy will warn about this. Interesting. Why is that? What is the ampersand bracket t bracket? Why is that specifically better? Because it produces a slice. Okay. I have to look up slices. I mean, I presume it's like slices in a lot of other languages. It's basically a sort of passive introspection into an existing structure in a way that allows you to do skipping and other subsections. So ampersand vec is a double indirection. Oh, is it? Because a vector is a struct, and structs tend to live on the heap. So what I'm effectively doing is getting a reference to or a pointer to a pointer under the hood, I guess, effectively. I'm guessing is what you mean by that. So I can see that. That makes a lot of sense. Interesting. I will have to remember that because I would not have glommed onto that early. Anyway, take a look at what your output is. Your output is, in fact, exactly what the standard zip does, which it corresponds to exactly what mine does. So let's actually do these changes and play with SilenZ's version of this. I like this. This is really cool. This is what I would have eventually gotten to, I'm sure. I love that you're helping me get there a little bit early. Yeah. Yeah, I actually like this while let mechanism better than this mechanism, just because I don't need to deal with the various ways to break out of the loop. It's effectively implicit in the way the let operation pattern matching works. That's just so beautiful. Anyway, going back to, let's do the ampersand there and the ampersand here. So yeah, okay, I get why that's the case. So I'm doing a borrow. The borrow in this case implies an indirection, because it has to. Because that could be on a type that doesn't end up living on the heap, and because this one does, it's double indirection. I am following that. Okay. Whoops, compiling. Nope, I failed because I'm not paying attention, because this has to be... It's interesting that they tied indirection to the act of borrowing. I wonder if that was a necessary design consideration in the language. I don't actually know the answer to that. That would be interesting to know, and I suppose I will learn more about this as I dig further into Rust. So here we go. Let's run SilenZ's version on both of them now that it's been built in a way that it does not consume the VXs and VYs on the way in, like mine does not. And there we go. Oh, nope. It did not, because I did not reverse the... So this should actually have been VYs and VXs. So one quick little fix. And we all know this is almost certainly going to work. But just to be pedantic, let's compile again. I think once I get over some of the humps... of using trait objects the way I use type classes in Haskell to be able to pass around generic items. Once I get over that mental hump, I think I'll be able to write some pretty interesting stuff. Come on. Just run it. There we go. So equivalent. So SilenZ, very well done. I really like your solution operating on Vex. Now again, obviously, what I really want to do is get to the point of, first of all, getting this operating on passing and iterators. Don't tell me the answer to that. I totally love this answer because it just sort of refines where I was going much faster than I could have. But give me a moment to try to figure out the iterator stuff on my own. It may take me a bit. But I really like this. Thank you for making this suggestion. It runs like a charm, does what it says on the tin, and it's pretty. And I really like the width capacity because you know exactly what the length is going to be. Although, here's an interesting point. This works really fast because I'm willing to bet that because B is an actual vec and A is an actual vec, that the len operation is in constant time. I bet you can't do that with the iterators because you don't know ahead of time what the length is from the iterator itself. You could correct me on this. I should look up in the iterator, but I didn't see anything relating to length, except that you could possibly get it out of it by iterating until the end. But then you would have to make 2 passes on this just to get the capacity. And then, so you trade off the extra passes over the lazy lists, the iterators. I call them lazy lists because that's basically what you use in Haskell. You iterate over each of them once in order to get the length. You're going to iterate over the longer one even though you don't necessarily have to. And you would get the capacity, which would keep the vector exactly the right size, but you would do so at extra passes through the data. But as long as you do have access to that length, I love this solution. This is great. This is really great. I love it. Okay. So let's go back into, you know what? I'm not going to lose this for the moment. Let's just make a new version of mine. So I'm just going to put a major comment here. Silent Z's implementation. Love it. But I'm actually going to pull this out of my code, and the reason why is because I don't want to accidentally leave it in there and it end up in some other archive of mine. But I love that. So it'll live forever in the video stream, obviously. What I'm going to do, actually, though, is I'm going to... That was a lot of fun. I'm grinning on this side. Don't have a webcam up, but I'm grinning. I love that. So let's put 2 of these back in. Well, one of the pair of them back in. Because I'm going to go down the iterator side of this. So what I really want to do is I want to look at the various types of iterators. Sweet. All right. I will leave the Twitch stream. Don't need to be playing a stream that I've trying to balance my my stream load here. All right, so that was very cool. I'm going to take this and massage it to use the iterators, and I might do I want to? You know what? I'm going to leave my slightly janky for loop in here. I mean, it's not janky; it does what it says on the tin. But I'm going to leave it in this form rather than Silent Z's form because I mean, I love what he did with the thing, but I want to make sure that I am fully understanding. Let's do this, though. Oh, except that in order for... Okay, nope. First things first, then. I want to make sure that this actually works on all T and not just I32s. And more importantly, I want to make sure that it works on the T's and the Y's. That is one modification I'm going to make to this in order to bring it up to par with what Silent Z was doing. So... to do that, I'm going to go back to here and temporarily pull these iters out of here. Nope, not that one. I am never going to get to the original starter. This is going to be a multi-parter. It's just going to be a multi-parter. That's going to be a lot of fun, though. Okay, so this is number 2. All right, so I am going to comment this out. Oh, really? Programmer's Notepad. How do I do a comment out, please? Comments. Control plus comma, really? Nope, because I don't have this set up to be a particular... Great. Do I have... no, Rust is not in... Oh, boo! Programmer's Notepad doesn't have a scheme I can use. That's really... come on, guys. All right. So there has to be a way to do a quick comment out on this. comments. Yeah, do the line, just control, yeah. Oh, except it's not doing a comment like I would like. This is close enough to C++ that I'm going to use it, because the only thing I really want to do here is that. There we go. I should probably just pull this into Visual Studio or something where I know the editor better, but whatever. I'm just doing really basic edits. Okay. All right. So let's do a version of this where I'm just going to preserve that. That's my whole point for doing this. Bring this down closer to main. All right. So first things first, let's T and U, T and U, T and U, and actually I probably don't even need this because I can probably deduce the type. Okay. Oops. Come on, really? How? There we go. I found a way to minimize my OBS so that it's not interfering with me and confusing me. I keep clicking on the OBS background because it's showing all the windows, so I click on one of those faux windows in order to, well, whatever. Right. So let's give this another go. Now, if we try to compile this, I cannot find T in this scope, and oh yeah, of course, because it does actually require me to list these ahead of time, so that's fine. And actually, yeah, I think that's enough actually to be able to do this. So, all right, hang on. But I know there's going to be problems, probably relating if I'm going to guess. So found so expected. My zip, because I do not have the ampersands in front of here anymore, and I'm doing a borrow. So I'm borrowing from main. I'm not taking ownership. Cannot move out of X, which is behind a shared reference. Out of Y, which is behind a shared reference. Okay. And that's where the copy trait comes in. So a move occurs because star Y has type U, which does not implement the copy trait. All right, so let's talk about this for a second. Okay, so I passed in effectively saying that I'm borrowing from the vec t. Sorry, when I do x in XS iter, I'm actually getting out effectively what is a reference to the element, which means I'm borrowing that element. I'm looking at it, but I don't own it. And so when I dereference it, I do not want to. It's a shared reference, which means that trying to figure out how to phrase this to fit this in my head. What's the best way to explain this to myself? Because I don't want to fall into the pattern of assuming this behaves like C++ and C# and the like when it does their kinds of dereferencing. So effectively okay, I need if it's clonable, then asking it to dereferencing it to get past the borrow means it has to do some kind of operation in order for me to take ownership of it out of a reference. I think the only way it can do that is by doing by making it clonable, which is why In Silent Z's version, he had the t's effectively being clonable, the t and u's being clonable items, because then this code would effectively work. And actually, he explicitly called the clone operation in order to do that. That's interesting. All right, I will actually do the Rust C explain E0507. Here a bar value is moved out. Okay. That is not as helpful as you might think. That's a little bit, avoid moving the variable, somehow reclaim the ownership, implement the copy trait on the type. Here the nothing is true method takes the ownership of self. Self cannot be moved. Except I don't want to talk about the ownership of self just yet. So I'm going to actually go over to here and go with Rust shared borrow. A piece of data can be borrowed by a single or multiple users, but data should not be altered. A piece of data can be borrowed and altered by a single user when it's mutable. It can be borrowed and altered by a single user, but the data should not be accessible for other users at that time. Totally reasonable. There are very important rules regarding borrowing. Once a piece of data can be borrowed, either as a shared borrow or as a mutable borrow at any one time, but not both. Borrowing applies for both copy types and move types. Okay. One possibility is to make X clonable, and I do want to build up a new object, a new object from the old object. I'm not trying to do anything clever, like build up a collection of references to somebody else's data. This needs to live in and of itself. So X does have to be clonable. The individual items coming out of here do have to be clonable. If I dereference a borrow, all right, I have to look up what is the effect on borrowing when I dereference it. So Rust dereferencing borrow. What does that actually do? That's going to take me a little longer to read than I want. I think I've gone into this web page before. The issue with the tuple code, we have to return the string to the calling function. Okay, so the opposite of referencing by using ampersand is dereferencing, which is accomplished with the dereference operator star. We'll see some uses of the dereferencing operator in Chapter 8 and discuss details of dereferencing in Chapter 15. So I'm going to have to read all of this at some point. So let's take a closer look at the function call. But what I really want to talk about here similar rule exists for combining mutable and immutable references. I need to look up specifically dereference in here. We'll see some uses in Chapter 8 and discusses details of dereferencing in Chapter 15, so I'm probably not going to get a lot on it in here. Okay. Without getting too deep then into what this means, let's say that we actually say that T has to be clonable. Because without that, I can't get anywhere. I cannot move out of star X, which is behind a shared reference. Did I not save before I recompiled? Oh, interesting. It's not the clone in this case, it's the copy trait. Okay, well, okay, so the other way that I could do this is to do, make it copyable instead of clonable. Now I need to know the difference between those two because I need to know how this crap works. And there you go, it compiles. So that's fine. So if I run merge-zip.exe, that should be okay. That should produce exactly what I expected output for the one kind of zip, and then the other one will sort of work by definition. So now that works, and now I have to ask the question, Rust, difference between copy and clone. Clone is designed for arbitrary duplications. A clone implementation of type T can do arbitrarily complicated operations required to create a new T. It is a normal trait other than being in the prelude, and so requires being used like a normal trait with method calls. The copy trait represents values that can be safely duplicated via memcopy. Things like reassignments and passing an argument by value to a function are always memcopies, and so for copy types, the compiler understands that it doesn't need to consider those a move. Interesting. And that's a good distinction, actually. I think copy types can't have custom drop impl. Yes, so I haven't dug deeply into how the whole drop thing works, but I have encountered the drop impl mentioned as a consequence of, I was looking up how Rust might do, what is it called? Tail recursion elimination, because that's something that I like having access to, and I know Rust doesn't have it, so I was reading discussions. So if I'm not mistaken, the drop impl is basically operator delete. It's doing a delete operation like in C++ or a free in C or whatever, but with the destructor. Yeah, drop is destructor. Got it. So that makes a lot of sense, and I actually appreciate that distinction. So that's an interesting thing. What I have done here is the sort of the version that would only work on things that were not allocated on the heap, or at least had a way to be memcopied safely. And that's an interesting distinction. Maybe you can tell me this. Is it possible for Rust to have aggregate types like structs living on the stack? I was under the impression that the automatic implication of being a struct is that it lived on the heap, but that would be an interesting question, right? Because then one would argue, I guess you couldn't expand the copy trait to another thing necessarily. Unless, nope, too much speculation. I'm going to go down a rabbit hole I don't need to go down. So what I've done here, so structs usually live, do they live on the stack? What ends up on the heap then? Oh, that's interesting. I'll have to think about that. Moving right along. So what I've done here is, this will only work on things that can have a memcopy trivially. Box T is on the... Oh, right! I forgot that. Box T being sort of a specialized built-in type that does the heap operations. That's actually really cool. I mean, because it's easily recognizable as something that's on the heap. I mean... That there is a way to get control over having things on the stack and heap is good. I like that. I don't like C++. I always got very used to, because the way to put things on a heap was to put new in front of it, and I got really used to that. It's like that is the indicator that something is living on the heap almost always, or something that eventually devolves into doing that. When I got to C#, the distinction was using a struct versus a class, which bothered me to no end, but that's just because I came from a C++ background. This is option number 3, where we have a sort of a wrapper that's like unique pointer or shared pointer. Don't know that much C++. Actually, yes, that is actually a really good analogy. Probably not a perfect one, but for those of you who don't know C++ very well, we should have abandoned raw pointers to things that use new and delete on. a long time ago in C++, and actually very early on we started migrating to smart pointers, which are basically just classes. Yeah. Very much like very much like shared pointer. I can understand that now. That makes a lot of sense. We abandoned using, or we should have by now, abandoned using raw pointers for doing any sort of object management in C++. Wrapping it in a shared pointer and unique pointer does some of the effect of the ownership management that Rust does. Rust just happens to do it better. So, from what I can already see. Yeah. Yeah, that's a really good analogy. Okay, so now I know that, right? And that's actually really cool because there's a lot of things that I like doing that involve putting things on the stack on purpose because it much less cleanup required. It's something that's temporary that I can do work on a block of memory, and then at the end of the function it just goes away. No muss, no fuss. Really low latency. It's no fragmentation. And languages that don't have the ability to put things on the stack do drive me a little bit bonkers sometimes when I'm trying to get down to that low level. For arbitrary abstractions, though, where I'm just writing code that I don't care about that sort of thing, then I don't want to see it at all. So I like Haskell, actually. Anyway, because there everything's a value, but it's all heap or stack managed for you, and you don't have to think about it. Right. All right. Where was I? I was going into trying to iterify this. So now that I've understood how this works, I'm going to get rid of that one. I'm going to clone this one. I'm not sure that it really matters because I didn't really change much. I'm going to use the newly found comment everything key function. And I'm going to I am going to look at how to make this an iterator. So what I need to do is I need to go into the standard, not standard clone, no, standard iter. Trait is an iterator. Okay. But what I really need to be able to do is know how to pass iterators in and out of things. You know what's really funny? When I first started learning Rust a couple of years ago now, maybe a year and a half ago, I actually implemented a really nice little binary tree that stores stuff on the heap, and it actually worked, and it all did the borrowing fine, and I've forgotten how I did any of that. It's very frustrating. I'm going to push harder on Rust this time to actually learn it and keep it in my head. So we're going to look up, trying to keep this in the same window as all the other stuff I'm doing, just so that there we go, just so that everyone can see what I'm doing. Here we go. We are going to look up Rust trait objects, trait parameters, trait objects, because I need to be able to so using trait objects that allow for different types of one limitation of vectors is it can store elements of only one type. We created a workaround where we defined a spreadsheet selling them that had variance. Trait for a common behavior. This is not quite what I'm after. I was after the composability of two iterators. And actually, what I kind of want... So by implementing the into iterator for a type, you define how it will be converted to an iterator. This is common for types which describe a collection. One benefit is that your loop will work with Rust's for loop syntax. Well, that makes sense. And specifically, it returns the trait. It returns self as a as an into iterator, or self : into iterator. I'm gonna have to figure out how to implement these. What I really need to do, though, I need to create an iterator effectively of a new type that is essentially a linear, sort of a linear operation, linearly counting operation based on another pair of iterators. So, what if I created? I've got an idea. I've got a thought. I've got a cunning plan. Trait objects equals vtables. Yeah, I kind of got that. Except the interesting thing, that is interesting. It is a vtable, right? Because that's the thing in C++. You always had your vtables buried as hidden parameters inside all of the objects you were passing around. Perfectly sensible, works fine. Does have problems when you're composing objects together, because then you have to look up different spots in memory relative to the start of your object where various kinds of vtables were. You didn't have to do any of that manually. In most cases, the compiler took care of all that, but it was carried around with the object. In Haskell, and it looks like to some degree in Rust, these parameters are passed around separately. Like, you don't pass around vtables on their own in C++, except sort of, I suppose, implicitly by passing around pointers of an interface type, but it's not really a separate thing. And in Haskell, it actually ends up being passed around as an implicit parameter to functions, the dictionaries / vtables or whatever, lookup tables for functions, which I found a fascinating thing, because then all of your data was just data. You didn't have anything arbitrarily attached to it, which I found very cool. Because there's no reason you couldn't pass around as implicit parameters to functions. Yeah, okay, so Rust structs. Because I'm going to need to know this, because I am definitely going to be producing. I want to produce a new iterator from old iterators. I don't want to create a new iterator into a new container. I don't want to create, and I don't want to put it in a formal structure and then pass out an iterator to that structure, because I don't need to. This can be entirely lazy. It was lazy in my C# version. It should be lazy here as well. There's absolutely no reason not to do that. So going into structures, yeah, okay, so name structures, no big deal. All right, so what we need is a structure, but we need it to be templated, so it's going to be struct myZip. We can just label it like that, because I think there's a zip structure for other myZip, which is going to be based on T and U. Come on, fingers. Learn the typing thing. And then we are going to do let's bring this down to where it's actually going to be used. We are going to have, we need an iterator of some kind here, except it's going to need to be, oh, that's interesting. I actually need this, not necessarily to store the T and the U, but to store, can I actually have, I am speaking in half sentences because I'm not even sure where I'm going with this. What I want is I want a variable type of a trait type based on the iterator class. So trait objects, where was I just talking about? SSTR clone. And I have no idea where the iterator type has gone to, so I have a million tabs open by the end of this. Rust iter. Let's open that right back up again, because what I really want is I want conversion into, so these are all traits, pile of structs, iterator that clones the elements, iterator that iterates two other iterators simultaneously. That's great. I don't want to use that because that kind of feels like cheating. What I want to do is I kind of want to implement this actually. Except it looks like, okay, so here's an interesting problem. It looks like I might have to implement it for a number of different types of iterators, which is unfortunate. I'd like to be able to abstract over the iterator itself, but that would require higher kinded types, because basically, and that's another thing I know that I know Rust does not yet have. I hope it does eventually, because I think Rust's type system could become as powerful as Haskell's in time. But what I would like to be able to do, for example, is like at the moment I would have to do something like this. I would have to have like iterator t as being one of the types, and I'm going to get the order of the. So here you go, I1. Right, I can do this, and then I can do this. And that's great, but that's only going to work for the iterator type. It may not work, for example, for the fused iterator type or the trusted len iterator type. And unless these all boil down to, unless these all ultimately boil down to well, maybe it doesn't really matter, because these are all traits and they can be combinable. They're all super traits of iterator. Yeah. See, I'm thinking like the C++ side of my brain and the Haskell side of my brain is thinking what I would want is something that basically a type of template or a type of generic that itself needs a couple of generics. So this is basically a second order. This is what Haskell would call a higher kind of type. And then what I would do is basically something like this. I'd basically have I of T and U. And that would enable me to abstract on the actual iterator type. This kind of thing has its own problems, though, doing it specifically this way. All right. I'm just actually going to start with iterator U and T and see how far I get. It just bothers me, I suppose, a little bit that what I'm seeing effectively, that what I have to implement is have a bunch of different implementations for the different kinds of iterators in order to be able to be used in certain circumstances. Oh, well, you know what? I'll have to learn about all these. That's fine. I'll have to learn about all these. I'm going to implement a basic iterator. I'm not going to get fancy with this. I'm hoping it'll be enough for the moment. We'll see how far we get. But basically, this will contain the two iterators that I'm going to be iterating across, basically the x's and the y's. In fact, let's just call that ix and iy, because let's just try to map it directly to what I'm seeing in my zip. Yeah. Exciting. All right, so we need actually an impl, and I have to figure out how to. Okay, so I'm going to. All right. Impl ab iterator for. My zip AB. So isn't that interesting? Fields admitted. Iterators are lazy and do nothing unless consumed. Yes, okay, I got that. Iterator, okay, so that's fine. So I'm basically going to try to create a simpler version of this just to fully understand how the iterator mechanics work. And then what I'll probably do is slowly get rid of this. The problem is when I go to my own personal merge zip that I showed the Haskell, C# and C++ versions at the very start of the stream, it wasn't a zip function. So although my rebuilding a version of zip makes no sense in practice in Rust, because hey, you've already got categories of traits, whatever, for doing this sort of thing, I don't have one for the thing that I'm eventually going to do, so I'm going to learn how to do it here before I go and learn it over there. because I'm going to be iterating over these not in lockstep, and all of these will have been implemented in lockstep. Auto trait implementations. Interesting. I'm going to have to look up how those work. I got so much to learn. Whole type system in this thing is going to break my brain. Right. So Rust. Impl for trait. Traits, defining shared behavior. Right. Returning types that implement traits. Oh, that's nice. We can use the impl trait syntax in the return position to return a value of some type that implements a trait. So that's how I do return types of returns of objects whose type is not necessarily whose return type is not necessarily knowable except for the fact that it returns a type. So I'm only returning the vtable effectively. Well, a vtable plus, I guess, an attached abstract pointer that represents the object, which I guess is ultimately just an interface like in C and C++, sort of. However, you can only use impl trait if you're returning a single type. This code returns, yes, okay, that's fine. Finding largest function with a trait bound. What I'm really after here is how I do the impl side of things. Use trait bounds to conditionally implement methods. That'll be a lot of fun to experiment with. I got really into doing a lot of type wizardry with template metaprogramming in C++, and trying to apply some of those techniques over in C# for a while. I mean, I still do that because I do a lot of that stuff for work. Sort of. Okay. But that's defining a trait. Implementing a trait on a type. That's what I'm actually after right here. So what we have is impl summary for tweet. Now the only difference between this version that I see on screen here and the one I'm doing is obviously I need to specify the types that are involved. But I also need that where clause that seemed to be implied. So because I need to constrain for my purposes. I need T to be clonable or copyable. Let's stick with copy for the moment. But that means I need to constrain is that where I can actually put those constraints? I don't know. Rust generic function constraints bounds. Type runners must use traits as bounds to stipulate what functionality a type implements. That's totally reasonable. So in a function, I can constrain it here. In a struct, I can constrain it in the struct section. So I think I could do, let's just keep the naming consistent. Oh, unless you see the din keyword, there's no vtable, the generics get monomorphized, by which you mean, if I understand that word correctly, that the substitution of the type at effectively the call site deduced by the compiler effectively clones the code with the substitution in place such that everything is concrete. Like it's a concrete type rather than some sort of generic. Because I know C++ does that. That's its whole thing. That's not what C# does, and it drives me flippin' bonkers. Okay. It's been a very productive day, actually. I'm quite enjoying it. So tnew. I'm not even sure, though, if I need to do that. So for an implementation, All right, hang on. Before I start like throwing these around like candy. So the basic syntax is that I have to provide functions for each of the things that the iterator expects. So going back to wherever the heck I left the iterator code. That's for iter zip. std iterator. So the only thing I have to implement in principle, so I have to have a type in there. So that's type item usize. We'll be counting with usize. That's interesting. Am I actually obligated to... Okay, so type item equals, except that it's not actually the types T and U that I'm after here, is it? It's actually the two kinds of iterators. Because I can extract the type information I need. The thing it's iterating over. This is a trick, obviously, I picked up from the generics. Yes, about the monomorphization. Yes. I like that in C++. I think it's the right way to solve these things. I don't like the way they do it in Java and C#, where they do this sort of like total type erasure, because then you have to do too much work in some cases at runtime to try to re-extract what the real type is, and it just creates a... I literally wanted in C# a way to have a function that took in two parameters, performed a math operation, and returned a result, and I wanted the types of the parameters to be generic, and I just wanted a T that could be an int and a U that could be a double, and then I wanted to perform a plus operation on them and have them work. And the two ways to do that are either full monomorphization, where it simply does the plus operation after all the types have been substituted, and if it works, it works. That sort of duck typing thing that C++ is so good at. Or you do the Haskell / Rust way, which is more like, which appears to be more like, on the inside of the function, you still don't know anything like you don't know in C#, except that you have really, really good constraints on traits on the types that can enable you to do it. Like in Haskell, there's a num trait called a type class there that gives you the plus and minus operations, for example. And for a generic type, you just have to specify, hey, you got to give me values that support these operations. And in C# you just don't have that, or you have to roll your own. Drives me nuts. One of the two, right? C++ duck typing or Haskell type classes, and Rust has, in that sense, gone the Haskell route, and I like that. That's fine, totally doable. But monomorphization has its uses elsewhere. From what I see, don't get me wrong, I'm just getting a handle on the way Rust is doing things. Making a lot of assumptions, educated guesses, sometimes not good ones. So type item equals, I can do actually a, might be able to do, can I do a : item? Is that a thing? Can I even do that? I want to be able to extract A's item field. Because I'm just going to use A. No, it's not. It's actually, the type is actually, is actually A item. B item in a tuple. I mean, I don't know if that's the correct syntax for extracting A and B's items, but assuming A and B themselves are iterators. And actually, it's not A that needs to be the copy, though. Oh, this is going to be an interesting problem. Oh, I'm going to have a lot of fun trying to fight through this. Right. So what I need to do is this. Self needs to be mutable. That's fine. Let's get my braces properly working so nobody whines at me for that. And instead of doing the example here where I'm doing a count, basically what I'm doing is I have access to the members of the fields via self. So I'm going to actually use Silent Z's trick here because I think I should be able to do that. Which is use pattern matching if I can use an if-let on a tuple that I'm going to construct from self.ix.next, self.ix.next. And if I can pattern match on that, and it would have to pattern match on both of them. So if at least one of them is the none type, whatever that is, yes, it's none. Look at that, lots of Haskellism still in my brain, because they use a maybe type, which is a nothing or a just X. So exactly the same thing. So this deconstruction will only pass if both of them have something available. Then return. I can actually get away with the last thing in my function being an expression rather than an explicit return. And so let's go with that because that's the example I have here. By the way, love that Rust is very much inclined to be an expression-oriented language. And you see a little bit of that, for example, in C#'s lambdas. One of the ways you can write a lambda is simply have it be an expression. In the case of Haskell, everything's an expression. In the case of Rust, I like that you can either have it as an imperative return or as a value. I would rather write most of my code as almost purely value stuff because I really appreciate the functional style. But being able to do, like in this count example, being able to do mutation sort of internally before you decide to pump out a value, useful in some contexts. You've got to remember, this is not a functional language. It definitely has mutation, but it is controlled enough. And IX has to be, IX is going to end up having to be mutable. So I'll have to think about that in a moment. So this is going to, I'm not going to say return, I'm just going to say sum. Actually, somewhat ironically, it's literally just going to be this. Else. This is pretty. I like this. None. Okay. This is going to have type problems all over the dang place, but bear with me. Okay, so So this is going to have to be a, instead of being a borrowed vec, I'm actually going to make it a moved in iterator. Maybe. I'll have to think about what I mean by this. So this is going to be, I'm just going to make x's be I'm not going to get that syntax right. Rust mutable parameter. Okay, it is just mute x. Or in this case, yeah, so mute, so I'm going to call that mute self because I'm going to try to write, I'm going to try to rewrite this. Really not sure how to write this generic function. I do not know. Rust. Generic parameters. Sure. Sure. So I know that T's copyable and U's copyable, and what I really need is for this to be some kind of iterator T. So I wonder if my zip should be parameterized not on U and T, but on iterator. Except I don't want, so yeah, it has to be mutable because I'm going to be mutating iterator. So mute wise is a T. I do eventually want it to be of basic type iterator. Sorry, not T. I'm going to call this A and B. Express generics in a way that code doesn't run any slower using generic types, blah, blah, blah. Okay, so that's not helpful. I still need to, okay, I still need to check out. Oh, good heavens. Three forms of iteration. So that's really not helpful. I need... Since into iter takes self by value, using a for loop to iterate over a collection consumes that collection. So that's actually not really what I want to do. Oh, that's okay. I'm not thinking at that level. When hello adapters. Functions which take an iterator and return another iterator are often called iterator adapters, which I'd found this before. Common iterator adapters include map, take, and filter. For more, see the documentations. If an iterator adapter panics, the iterator will be in an unspecified but memory-safe state. State is not guaranteed to stay the same across all versions of Rust, so you should avoid relying on the exact values returned by an iterator which panicked. Okie dokie. That's totally fine. We're going to go to... sure, let's go and check out map. So how does map actually work? Takes a closure, which I'm going to figure out how to do eventually for my my merge zip at some point, and creates an iterator which calls that closure on each element. That's fine. So where f is equal to fn mute, so f is constrained as a function that eventually produces a b. So if I'm saying from an iterator point of view, iterator.map, self is going to end up being the implementation BIF iterator for map IF. I is the iterator, so it's doing what I thought I would have to do, which is that my iterator effectively has to know about the iterator type itself, and the return type for the return type becomes mapped by way of this constraint here. So that's how it gets automatically deduced, because that gets pulled out of F. So the return type, that's a dependency to construct the dependency to produce this. That's a nice way to say it, because remember in C++, trying to extract what the return the return type was of a function without actually calling it involved way back in C++ 11 a whole lot of jiggery-pokery, and it wasn't always terribly reliable. Now we have some really good built-in templates to help you pull that metadata out. This is a much better way to do it, because this is basically just along the lines of pattern matching. I did pick an awfully complicated problem to do all at once, didn't I? Oh well. I will eventually get there. It will be trial by fire, darn it. It may take more than one session, because this has already gone on for hours. 3 hours. I've been doing this for 3 hours. That's good, though. I'm learning loads. Don't get me wrong. I love the heck out of this stuff. So it's just so darn hot in here. And I have to get myself another glass of water shortly. Okay, so this is good though, because this kind of pattern matching at the type level will enable me to do what I want. And I did guess that one of the things that I'm going to want to know is I'm going to want the iterator type as part of this. But this is confusing to me. This function says self, but it's not tying. So yeah, it's not tying self to any particular type. So that's something that I don't yet understand. So here's what we're going to do. Rust self generic type. Safe and generic self-referential types. Nope, not run them after, I don't think. Using a generic trait as a trait parameter, generics as type classes. Sure, Rust design patterns. That's probably a good thing to work on. Because a lot of my growing love for Rust, aside from the borrow checker, is that it has a decent type system and generic system, somewhat threading the needle between C++ and Haskell. Safe and generic self-referential types. It's not really. I don't think that's really what I'm after. What I'm after is, does Rust generic? That's a terrible phrasing of that question. No, sorry. Rust self parameter. What types are valid for the self parameter of a method? So very quickly looking up their suggestion. Originally, Rust didn't have this explicit self form. Only self ampersand self for borrowing, I'm presuming, mute self, and tilde self, the old name for box. They used to actually use a there's an interesting thing. Do I like that or not, that they went with box instead of tilde self? Oh, whatever. Doesn't matter. It's changed so that only by value and by references have the shorthand built-in syntax, as since they are the common cases, and have very key language properties while all smart pointers require the explicit form, including box. Okay. As of Rust 1.33, some additional selected types are available for use of self, RC, arc, and pin. I'll get to those eventually too, I'm sure. This means the original example now works. So, right. Okay. So what that implies is that self is of, in fact, type whatever my type is. So going back to, my goodness. Yeah, going back to here. In this description of the map function, actually, where is this coming from, though? Is this the type of this always? Like, is this a reserved type? Self, in that case, is the iterator. Yeah. Okay, so, sorry, I need to keep looking at my chat a little more often because you are full of wisdom going on here. So here's the thing. Looking at the way... See, I'm deducing this basically from the documentation and some educated guesswork, but maybe you can tell me this directly. From this, like I would say deducing what all of the types are from all of this. I see, for example, the type of F is just deduced directly from the parameter. The type of B is deduced from the return type of F, so buried inside of F, because F, I guess, has to pattern match to fn mute self item. But self itself doesn't seem to deduce from anything. Oh, except it might deduce from fn mute. Is self capitalized like this a keyword? Not a keyword, but a reserved generic parameter to indicate the type of self? Or is it being actually deduced from inside fn mute? It's a reserved type. That's awesome. And that makes a lot of sense too, because you don't actually have, short of you manually specifying what its type is by using the colon syntax, which it says there are certain situations where that is not only probably allowable, but needs to be done. In the case where nothing is specified, you still might need to know what the actual type is. So that's great. That is fantastic. So that gives me what I need to solve this problem over on my iterator, because the iterator, I think, is going to need the same thing as what I got going on here, which is I'm going to be producing this iterator type. So, so I'm going to be using this iterator type. Somebody else is going to end up using this iterator type through its interface. I'm going to want to have a function that myzip that returns one of these. So it's actually going to be doing this logic, which it actually kind of implicitly is by doing this. So actually, I don't want to do any of this because I'm not actually producing a vector anymore. Yoink. What I actually kind of want to do, and this is not returning a vec anymore, it's returning, this is actually going to resemble a lot like the map example over here. So this is going to return a I'm not doing a zip with, so I do know what my return type here is. But I need to know I need to know the two iterators A and B. which correspond to, and one of them is actually going to be self. So gotta think about this, because this map type, right, okay, slowly getting my head wrapped around this. I don't need a function stored in here, so unlike the map example that we just saw where I accidentally scrolled way fast, though this is not helping me at all. Yeah, it's asking for an iterator and a function type. And this is how I would do it in C++. I would actually have my function type dictated by a generic, so that's fine. Yeah, so it's kind of this version where you're doing a function of mutability, fn mute, I guess. A function that mutates. No, a function that, what did fn mute even mean? All right, time to look that up. So the version of the call operator that takes a mutable receiver. Okay. Public trait fn mute args. fn once args, extern rust call. Oh, that's going to be fun. fn call mute. Okay, I'm not going to deal with that, because that is learning how to do effectively lambdas and the like closures in this is going to be a whole other thing. I'm going to have to defer that, I think, until tomorrow, or at least until the second stage of the stream. And I don't need it anyway, because the functional operation that I'm giving is just create tuple. Like, that's my zip, right? My zip width, when I go and invent that, we'll have to add another parameter. Right. Fun. So, so what this is going to do is this is actually going to return effectively my zip AB, and that's going to be my A, and that's going to be my B, and the my zip AB is going to have this is going to store my state, and because it's returning a type, because it's returning a myzip, it's effectively going to be usable as the left-hand side of future iterables, because future iterator adapters like maps and zips and all of those sorts of things. Because it is going to behave like an iterator, having a next property, which is why this exists. So it's basically doing, I'm going to end up, yeah, okay, that's fine. It doesn't even need to necessarily return a trait object, although that's an interesting question. Why do these not return trait objects? I'll have to think about that. So fn mute are closures that capture mutable reference. Yeah, okay, that makes sense. Fair enough. But I'm going to get to those eventually, because I'm going to need them, but I'm not going to deal with that side of this now, because that's a whole other thing for me to fight with, is learning how to do lambdas. Slowly getting there. I am bound and determined to get zip working. It may kill me, but right. So what would I do here? I would basically return a construction of this. So what new my zip AB. Actually, how do I construct it? There's something I haven't even done yet. Google Rust create new struct. I'm instantiating structs, mostly having to do with the fields. Yeah, so let user equals user and then just the bracket. I don't need the new thing in here at all. So, yike. So, yeah, just taking a look at more examples of this. So, I love value-oriented languages. It just makes me smile, because I can literally now just do this. My zip A, B, like expression oriented, I should say. So I just do that at my zyop because apparently I can't type today. So ix equals x, so actually equals xs. So actually these are kind of badly named because these are going to end up being iterators themselves. I'm going to have millions of bits of little iy. MyZip AB, that makes no sense there. Why am I doing that? Produces a MyZip AB, which is ix equals xs and a comma and then iy equals. Oh, there's an interesting question. There's probably some. Let's see here. Not self in context the MyZip struct. No, I know they're not trait objects. So you're right, I should stop using that term. Brain not functioning. I don't know how well this language deals with similarly named function names, so I'm just going to do this because I don't want to figure that out right now. So this is going to be returning a MyZip. Properly constructed, after which its state plus the implementation of iterator for that state should be sufficient to act as an iterator, maybe. So it's exciting and horrifying. And actually, MyZip is actually, so yeah, this is going to have to be. It's going to have to be mute self in order for this to actually behave. You know what? Let's not do that syntax just yet. Let's not make it. Let's actually operate as if this is an independent function just for the moment, and not try to daisy chain it with other iterators. That's one more step that I need to necessarily be polishing right now. So let's just do a compile, which of course explodes hideously, but that's all right. IX. So where did I get that from? That is expected comma or O, because these have to be commas because these are fields and not statements. That's fine. I can live with that. Next. Brace struct declarations are not followed by a semicolon because I'm thinking in C. Expected one of a whole bunch of operators, expected one of several possible tokens. Okay. User, email, username, active. Oh, so named fields separated by commas. Okay, so I have done that wrong. It's not an equal sign, but that's very much a Haskellism that I've done here, and that's fine. So actually, I can just do, in principle, I think I can do just this. You don't need to specify generic so you're constructing the struct because I'm willing to bet type deduction, which, by the way, I love. So totally, you don't need to specify generic so you're constructing the struct, or you can't. Oh, interesting. Okay, well, I'll get there. I'll get there. Interesting thing. All right, so what do we got here? Cannot find IX in this scope because I'm an idiot, because I renamed it, and I don't need to. In fact, I can do that now. I don't mind using positional information here. The structure is too small to need manual naming of anything. Associated type item not found in A. Okay. Okay. It's probably because I haven't constrained what A and B are so that it knows that it can find that. I need this to specifically be an iterator. Brain slowly turning to mush. Rust iterator trait. Yeah, there it is. So I need to constrain this to be an iterator. So if I say my zip, so in order to construct when I construct this thing, I need, is this how I do this? I think something like this. Expected option, A as iterator item, B as iterator item because of the return type. Right. It's not, so hang on. Options self.item. So hang on. I need, I'm a moron. Right. It's actually this. There we go. It's actually a pretty good error message. I'm okay with that. What do we got here? This function takes one argument with two arguments where it's applied. Sum x, y. Oh, because it's sum, it's a, being an idiot. It's actually some tuple of x, y. I'm getting there. I'm getting there. So, no field collect on type myzip. It's an unknown field. Oh, because it's supposed to be implementing no available field. Okay, hang on. No available fields are ix and iy. Can I do collect like this because I forgot the function brackets? See if that improves things. Maybe not. The method collect exists, but its trait bounds are not specified. Method collect not found for this does not satisfy that it is an iterator. That myzip, etc., is an iterator. Okay, except that I am implementing. I'm implementing iterator for myzip, so method collect is not found for this. Okay. Doesn't satisfy. Okay, so it's warning me. So the method collect exists for the struct, but its trait bounds were not satisfied. Okay. The following trait bounds are not satisfied. Vec I32 iterator, which is required because these are not mutable. So the mutability of A and B. So A is an iterator, B is an iterator, for etc. But I need it to be, but where A and B are those types, I don't think the mutability was carried along with them. Okay. Missing a lifetime specifier. Right, this is where I get into lifetime weirdness because I have to say how long that item lasts compared to me. Consider introducing a named lifetime partner or parameter. I'm missing, so, or Okay. If I don't do that and I keep the mutability, can I say that A has to be constrained to being a mutable iterator? Expected 1 of 9 possible tokens, which is not one of the ones it was looking for. I can't specify that, so I advise to implement just an owning version for now. Yeah, you're right. That's silly. But what I do need to do, I think, is make these mutable, because they do have to be mutable in order to be able to iterate, in order to be able to alter those with the next operation as I operate down the line. So you're absolutely right. I'm going to make this, I'm going to avoid using, I'm going to make everything value oriented until I don't have any choice, like owning value oriented. Sorry, ignore the value oriented part. That's a whole other language thing that I'm bringing into this that isn't helping. Owning is the better way to say that. Expected type found mute. Okay, so I can't specify that that's mutable here. All right. All right, so the following trait bounds were not satisfied. I need... Oh, well, except in order to use collect, the problem is in order to use collect, it may need to be passed which is required by myzip : etc. iterator. Help items from traits can only be used if the trait is implemented and in scope. Following trait defines an item collect. Perhaps you need to implement it. Candidate 1 iterator. Okay. This is the new fight. Method cannot be called on myzip borrowed vec I32, borrowed vec I32. Where the heck am I even using? So what are A and B here? IX and IY, which I marked as mutable. Problem is that iterator is only implemented no, actually I'm not, or I shouldn't. Oh, dang it, I thought I had altered this. See, pay attention to chat. I'm totally giving it vex. I didn't think I was giving it vex, and that's why I was baffled, and now the error makes a million times more sense. Zing! Because I thought I had already done this, which is where I wanted to go with that. So it's VX's actually, and so my confusion was with what I was actually passing, and I was assuming I was passing a different thing. Okay, so now I'm going to get a whole different collection of errors. Thank you for spotting that. Very clever. Type annotations needed. So this is vx's.iter, vy's.iter.collect. And it's not able to deduce a return type from that for reasons. Because I am not sure. Let's go and take a look at why that might be. Because I could probably, you know what, let's annotate it to begin with and just see if we can get it working. Because that's fine. So this is going to end up being, because it doesn't know what to collect into, because it doesn't have any surrounding type information, because it could collect into, because I don't think collect necessarily outputs to a vector alone, right? It might output to something else. Could be hash map, vec, or even result. Yeah, exactly. Okay. See, this is another bit of weirdness. There's not many languages. I'm not going to say overload is the wrong way. Not a lot of languages type deduce on return type nearly as much as, for example, Haskell and apparently Rust do. So I gotta retrain my brain to start looking for that. That's really cool. That's really, really cool, because I presume if I used that variable in a context like calling another function that expected a vector, it would all type deduce everything, and I wouldn't have to do anything. But all I'm doing is printing, and printing alone doesn't do any sort of impose any sort of type constraint on at the type deduction level for what this type is. It's just going to iterate through the items. I just write a standard iterator to iterate over the items inside this macro or something. I still haven't figured out macros. Don't get me started on macros. So okay, that makes total sense. So this is actually a vec of something. Let's see if that is enough information. Ha 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 ha. That just, wow, the endorphin rush. Okay, so remove this this mute. That's fine. Let me get to that in a second here. So, boy, that just makes me all kinds of happy. So if I reduce this, basically this is saying that I do not need this to be mutable, because why? Because I'm making a copy of this when I'm building this structure, because perhaps iterators are clonable, if I were to make a guess. It's interesting that it has enough information to tell me that that does not need to be mutable, because I'm not mutating it. I am copying it somewhere. I expected I needed to be mutable so that that information was passed down, but of course I'm losing that information at this level, and I don't need it at this level. Oh, but that's an interesting question then. I consumed... so I consumed the iterator. It gets owned by this function to begin with. Then it gets owned by this, and that means that by the time I finish building this structure, my zip doesn't even have ownership of it anymore. Main certainly doesn't, but I don't care, because I'm calling, .iter every time I want to use it anyway. I'm building up a new one, so that's not a big deal. All right, so let's run this thing, because it's been too long since we've run this thing. Check that action out. Gah! Oh, that feels so good. That feels so good, because I'm slowly starting to understand this and starting to unwrap my brain from other languages' idioms that I need to drop for the sake of learning. So we're just going to do this just to verify that this version of it works. Yeah, Silent Z, feel free to stop by my programming streams anytime. I mostly do game stuff, but this is a rush. That's all I can say about that. So let's check this out. So this is going to be... All right. Let's run this again. Yeah, so again, I'm generating a brand new iterator out of these calls, and I'm perfectly happy to have it consumed. I don't need them shared. Oh, hello. I've got a new chunk of code to show me some bit of wizardry. Am I going to be thoroughly embarrassed by this? Probably. Let's see it. I gotta love this. Let's check this out. Yeah, totally flex your version. This is the appropriate time to flex your version. Okay, so checking yours out, and I can't really show this on screen, but hang on a second. But I will take a look at this. Maybe I can show it on screen. And you know what? I won't for the moment, but because I didn't show the last one by pasting it into my code. Actually, I will test your code. So struct zip. So it's got a T1 and an I1 and I2. Yeah, I should have called it I, because I do that, and yeah, that makes total sense. as a naming convention. A and B, that's fine. Impl, the iterator, so I'm going to compare against mine here. Do you mind, actually, question, hang on, I got to go back to Twitch. Do you mind if I, the 2 bonus sections, do you mind if I show the window of your code on screen? Silent Z. I don't want to make assumptions just because you wanted me to paste the code into my the last version of your code, but you don't mind. Okay, I will show your code then, because I can do that with a little bit of where the heck did my Twitch window go to? It is over here. Yep, got it. Okay. I am going to thank you, by the way. That is exactly the right way. Let me fumble around, as painful and slow as it is, until I work my way through it, and then show me a really much sort of cleaner way, or with bonus code. That just makes me happy. That makes me all kind of happy. So I think, yes, I do have it now. I'm going to temporarily... Can I do this without breaking everything? Is it going to scroll or expand the right way? All right, good. So let's take a look here. So in comparison, Silent Z's code looks like this, and it looks a lot like mine. So this makes sense. We have the impl iterator for zip. That's fine. I see. That's interesting. So you've taken the constraints out of here and put them in where clauses, which I have noticed in some of the example code and I have not used yet. I'm glad that that's comparable. Then a question to you, Silent Z: is there a good rule of thumb as to when to put the constraints in the generic parameters at this point of the list, or in the where clauses? The wheres seem cleaner, but is there some other reason to do it or not do it? Anyway, so the function next needs a mutable self, produces an option self item. That's fine. Match self a next. Oh, using a match instead of a let. Good idea. It's actually equivalent for my purposes. Instead of using an if chain in Haskell, using a case, which has exactly this kind of sort of sequential pattern matching with a catch-all at the bottom. I love that. That's great. Use what's more readable. If it gets long, use where. Sure, perfect. I was just wondering if there was a semantic difference, and that's really cool. Okay, so yeah, I love the use of match. That's some nice wizardry right there, and that's totally the reason to use cases in Haskell when you start to get more than one thing. Also, a good reason to use guards in Haskell, in case anybody's into that language. To condense it down to when you have like lists of matches or conditionals. Anyway, oh, look at that hash test. Oh, that's cool. I'm gonna have to learn how to do that. That's some nice wizardry there. Bonus constructor for zip from into iterators. Okay, so let's take a look at this impl, and this is another impl zip, and the difference is okay, let me take a look at the comparison here. Bonus constructor for zip from into iterators. I don't recognize this syntax because this impl syntax doesn't match the previous one. This is saying impl is saying implement nothing for zip I1, I2, or some generic sort of global scope. Implement new produces self. Oh, this is interesting. So this is is this effectively a conversion constructor kind of syntax? Method impulse for zip. Okay, I'm working through this. So what this is saying is C1 and C2 can be some kind of types that. Oh, this is it. And this is some nice wizardry. So this is an internal generic method inside the implementation. Point is, you can still call zip new with just vec or any type that can be made into iterator. Interesting. So if A is a container, I'm reading this as if A, I have altered the code. If A is a container and B is a container, we're defining oh, interesting. Okay, okay. I'm still working. I'm still working through this. I understand what you've done. I'm not sure how this semantically means that just yet. But let me get my thoughts wrapped around this. The thing, impulse something is just how you implement methods something. No, I get that. So, oh, this is on. Okay, so this is adding. Right. This is just a method. This is just a method. Of course, I'm not implementing according to a trait. I'm just implementing a method because methods are kept separate from the data structures, which, again, very Haskell. Sorry, I apologize to any Rust stations who are in here who hate that I keep comparing it to that, but it's the closest thing that I have in my library, which is this tight on type stuff. And this is great. And there is a comparison here. Keeping the data structure completely separate from the implementations is really, really helpful. I like this. So, yeah, okay, so that's why that syntax makes sense. So this is just if I'm doing a new on two things and I extract and I can extract their types, C1 and C2, but they have to be of type into iterator, and then we're tying its parameter to I1 and I2. I see. Then we can make a zip that supplies B, A and B, coming from calling A's into iter and calling B's into iter. This is lovely. This is just lovely, because that saves a pile of boilerplate. So my understanding then is this is saying C1 has to implement into iterator, and we're providing this parameter. Okay, here's a question: why? Kind of curious why we can't get rid of the highlighted section here, the into iterator equals. Is this just because the generic parameter name is required in this context? This is clever, though. I tried, but the error was that the generics have to be constrained. Yeah, I thought you could just do, like, for example, I1 like that, because then I would think that it would have bound the first spot into iterator, which would have been, I guess, the into. Maybe if I respelled the type instead of using self. I don't know. But I'm definitely going to look at. That's interesting. So that's how you do new on this object. So instead of constructing it by fields, okay, how would I? So this is effectively how I would add it. So okay. So then, with my zip, so. I'm gonna have to. Oh wow. Okay. Vec 1, 2, 3. So that's just creating a vec and then using into iter, and then passing that iterator off into my zip with vec bang A and B. Oh, this is just lovely. This is absolutely lovely. So decomposing this. This is just taking this. This is just taking this as some sort of iterator. It doesn't matter what kind it is. And then sending that into the myZip function, which is gotta search for that now. Here, implementation of an iterator and B with my zip. Okay, this is going to take me a while to decompose. Not so much because of the type stuff, but because, okay, so this is two extensions methods. So actually, so adds a method on the iterator, right? So oh my. If A is an iterator and for some other type B, with my zip for the iterator, the implementation for A, as long as it's an iterator. So ignoring this, all you're really saying is for some implementation for some type A. It just happens to be that it happens to be constrained to the iterator, and then we have the myzip function. Nice, nice. So every iterator gets this myzip. Right, and it does a zip structure which I created. Yeah, this is great. A zip structure just like the one I created that provides self, which is an iterator, which is one of the iterators I need, and B, which is the other iterator. So B being the other iterator, right. Two bonus extension methods. This is fantastic. It's the implementation of this trait for A, which happens to be any iterator. Wow. Right. Where is with my zip used other than here? Literally only those two things. Because, so why, here's a question for you then. Why implemented as a trait rather than as a, can you even add a member to, because A is not a concrete type. I'm presuming you can only add methods to a concrete type. Because you've done this by way of a trait. Interesting. Can't implement, yeah, you can't implement methods on a foreign type. And this is basically the way around that, is just implement it via trait, because traits can be applied to anything. That's wild. That is super wild. Oh wow. Okay. I'm going to keep. If you leave this code up, I will probably refer to it in future streams. At least when I start implementing. When I start implementing the actual merge zip that I started this stream intending on implementing. Because now that I have this set up, I can now get to that, I think, because the version that I'm going to use is literally going to be a clone of this. It's just with different behavior on how the iterators do their thing. And so this is great. Okay. All right, so I'm currently coming up on 4 hours here. So I need to, at the very least, get myself a cup of something into me. Maybe some soup. I don't want to stop doing this, but if I don't get something into me, I'm probably not going to last many more hours. So what I'm going to do is I'm going to put this down for now, and I am going to continue another stream of this. I'm not entirely sure when. I might be able to do it this evening. If not, though, I will definitely do it tomorrow at a similar time. and I am going to go and implement the proper merge zip that I started this all out with and try to get it to match up with the C# and Haskell and C++ versions that I have already done. And in the meantime, I have a lot of Rust documentation to read. So, yeah, major shout out to Silent Z. I hope we touch base on this channel again. Love to have you back. If not, I really appreciate you coming by, because being able to talk through somebody about this in a very straightforward way, and letting me fumble and then providing me with a flex version for me to take a look at, very appreciated. I've learned a lot, and I'm going to keep pushing at this because I think this is a pretty fantastic language. I haven't got too many misgivings yet, and certainly fewer misgivings than in languages I already program in. So, love it. Right, so I have to say at this point, where is my magic stream here? I'm going to say thank you so much, everyone, for joining me on this stream. I will be back. No, I don't have a schedule. If people start liking what I'm doing here more and more as I do these streams, both these and my gaming streams, then maybe I'll start setting up a schedule and doing it more on the regular. I basically have to do this whenever I can find some spare time. I have really enjoyed doing this. Thanks to all of you. This is Codeweaver Writes Code, and I hope to see you back again in the next stream.